Hello everyone, my name is Rakesh and this is my second course in this SQL series. This course is mainly aimed for someone who is looking beyond the basics. If you're looking for absolute basics, I have another course recorded which is basically covering things like your environment setup and so on and so forth. So I would strongly encourage you to take that course if you're a complete beginner to SQL. So let's have a look. So what did we do in that course, right? We basically looked at the absolute minimum things that you would require in order to get started, right? So imagine you're probably preparing for an analyst job, right? An interview or something like that. And you want to know the absolute basics of right from the fact that what are databases, what is a table, what is data, how do I get my environment set up, what is a select query, how do I join two tables. All those things are covered in very detailed manner in the SQL 101 or the other course in my list of courses. This course, basically I like to call it as SQL 201, is a little bit advanced. Right? What we'll do is we will take all the concepts that we learned in SQL 101 and try to add more concepts to it. We will look at what are views, what are triggers, computed columns, and so on and so forth. Now, the overall aim in this is basically to get you familiar with the other concepts that SQL provides. We will be using the same approach that we took in our SQL 101. That is, we start with something super basic. We will look at what are views, what is the minimum in SQL, and at least get to a point where you can carry it forward further, right? So let's get started. It's going to be a fun course. Feel free to give me all sorts of comments through the discussion forums and stuff. I did take into account a lot of feedback that I received from my previous course to add some sort of quizzes or some homework assignments kind of a thing. So I will be adding those as well in this course. I will be sharing the scripts and keep the feedback coming. Thank you. Hello everyone. My name is Rakesh and this is my second course in this SQL series. This course is mainly aimed for someone who is looking beyond the basics. If you're looking for absolute basics, I have another course recorded which is basically covering things like your environment setup and so on and so forth. So I would strongly encourage you to take that course if you're a complete beginner to SQL. So let's have a look. So what did we do in that course, right? We basically looked at the absolute minimum things that you would require in order to get started, right? So imagine you're probably preparing for an analyst job, right? An interview or something like that. And you want to know the absolute basics of right from the fact that what are databases, what is a table, what is data, how do I get my environment set up, what is a select query, how do I join two tables. All those things are covered in very detailed manner in the SQL 101 or the other course in my list of courses. This course, basically I like to call it as SQL 201, is a little bit advanced. Right? What we'll do is we will take all the concepts that we learned in SQL 101 and try to add more concepts to it. We will look at what are views, what are triggers, computed columns, and so on and so forth. Now, the overall aim in this is basically to get you familiar with the other concepts that SQL provides. We will be using the same approach that we took in our SQL 101. That is, we start with something super basic. We will look at what are views, what is the minimum in SQL, and at least get to a point where you can carry it forward further, right? So let's get started. It's going to be a fun course. Feel free to give me all sorts of comments through the discussion forums and stuff. I did take into account a lot of feedback that I received from my previous course to add some sort of quizzes or some homework assignments kind of a thing. So I will be adding those as well in this course. I will be sharing the scripts and Keep the feedback coming. Thank you. So we looked at the concept of views in my previous session. And what we're going to do over here is actually go through some examples of views. So if you open your AdventureWorks database and go to the folder called views, it will actually show you all the views that have been created for this one. And you can look at the view definition as well, but let us just create a simple view so that you know what a view definition is, and then we can revisit this. Now, views can be actually created joining multiple tables as well. Now, there are various ways to create a view. SSMS also has some inbuilt tools that we can use to create views. So one of them is actually right click and say new view, and then it'll kind of open up a GUI for you in which you can actually select whatever things you need, whatever tables you need from the view, let's say name, etc. And then you can actually execute the query and see what it returns, and then save this. So say Control S, and then you give a view name. I'll call it as my first view, something like that. Right. The second way of doing this is actually something called as Template Explorer. And if you go to View and go to Template Explorer, you will find that there are many scripts that are written for you, and you can just use them. So if we scroll down, one of them is called as View, right? And if I double click on Create View, it kind of gives you a template of how a view is created. What is the general syntax for creating this view? And what you could do is you could go to Query and basically say specify values for template parameters and fill up these values. So once you fill up these values and click OK, it will actually replace those template placeholders with these values. So these are the two GUI based techniques in which you can actually create a view. The reason why I showed you this is that any concept that we discuss, most of them have some templates here, and that you can just use and go to your template explorer, go to your query parameters and actually fill them up. Now what we will do is we'll create a new query and we will actually write a query from the start. Before we do that, let's go ahead and look at our sales territory table, and that's what we have been using as an example for certain things. So our sales territory, if we choose the top 1000 rows, you find that it's a small table, a simple table. So let's use this to create our view. Okay. So what we'll do is we will select the rows where the country region code is US. So this view, we can call it as a US view, right? So let's try doing that. So I'll say the syntax is very simple. Oops. Create view, and then you can give any view name. So I can say my custom US view as, and then you give your selection criteria. This is your simple select query that you use. And in our case, it is nothing but select star from our sales territory table, that is this table. So I'll just copy paste this, where country region code like US. So before we execute the complete thing, let me just show you what this query will return. This query will return about 6 rows, and let's go ahead and create this view. Perfect. And now what we will do is we'll just run a select query, but this time against my view. So what it did is it saved your statements here and executed those statements when you actually queried your custom US view, right? So this is basically what I mentioned in my previous lecture, in which I said that you can create your view and then just give access to people for that view. And now this is just filtered down version for the US. Let's look at one more example, And what we'll do over here is let's look at another table called salesperson. Okay, let's just look at some sample data from there. And what we are going to do is we are going to take everything that's from North America. Let's have a look at this table again. Whatever is North America, and what we are going to do is we are going to join the other table. So I just wanted to give you an example of how two tables can be joined and put into a view, right? So let's see how that turns out. So I'm going to create a view. Again, the query is super simple. Create view, give any view name. So I'm saying NA sales quota as, and then you follow your select query. Select, let's say what all things we can choose from sales territory. I'm going to choose name. What else? Let's choose the group. Okay. Let's choose, okay, let's look at salesperson. Let's choose sales quota. Let's choose bonus. That should be fine. And let's just join both the tables. So from your sales territory, A, inner join with salesperson B on A dot territory ID equal to B dot territory ID. And since this is a North America view, I'm just going to write a simple where clause. I'm going to say that where group like North America. Okay, so let's test if our query works first before we create the view. Okay, let's make sure I'm using the adventure works. Let's try it again. Okay, so we have joined two tables. Now I'm going to create the view. And if I just run a select star from NA sales quota, I'm going to get the filtered version, right? So this is how you can deal with views. We looked at the GUI version, right click on views and then create your views. We looked at template explorer, and we also looked at how to write your custom queries in order to create your views. So very interesting concept, very simple concept. I would highly recommend try different things like joining multiple tables, giving security and stuff like that. There is some interesting stuff which I'll be uploading in quizzes that will give you more insights on views and will make you more curious on the different aspects of views and what are the other things that you can look out for. So I would highly suggest go through the questions as well. Thank you. Hello everyone. So in this session we will be talking a little bit about triggers, and triggers is one of my favorite topics, as it allows you to do a lot of things, and when you actually start getting deeper into databases you can really explore how powerful the concept of triggers are. So before we take a deep dive into the code, let's try to understand basically what are the triggers and how does this whole thing come into play in databases. So let's assume that you have a table, and let's call this as something like a simple sales table, right? Sales table. And let's assume this stores the sales ID, just a simple primary key. It stores the sales amount, sale amount. It stores the sale date, right? Let's keep it that simple. Now, your boss comes to you and says that, you know what, if there is a sale of say $1,000 for any date, right? For any date, there should be an automated email being sent. Okay. And then he comes back to you and says that, you know what, if there is a sale of say $1 million, right? Definitely this is some sort of an error. So what I want you to do is actually roll back that transaction, right? and then also email an alias, and at the same time log that into a database. Okay, so basically he wants to say that any hacking attempt or something, he wants it to be logged, and also making sure that other teams are aware of this. Okay, now basically he says that, you know what, if the total sales, right, total sales for a month, say sale date, right, for a month, if it exceeds say $5 million, then basically log an event in a database or in a table. So if you see what is common over here, you're doing something when some sort of an insert is happening, right? You're inserting a row, checking against a set of rules, and doing some action, right? And these actions are nothing but some set of statements, SQL statements, right? So what you're telling SQL is, you know, I'll give you certain conditions. If those conditions are true, then execute my set of statements, right? And that's precisely what is a trigger. Triggers are statements that are automatically updated, or automatically they are run when some sort of an insert, update, or delete happens to your table, right? You can actually predefine on insert what code should run, on update what code should run, on delete what code should run. So you can kind of imagine this as some automated check or automated set of scripts that get executed when some event, some activity happens in your tables, right? Depending upon your requirements, you could use it for various things. Like one of the things is logging, right? The other thing is maybe validation, and of course you could use some other concepts like database constraints and stuff, which don't worry about it for now, but some sort of validation, etc. Any set of statements, any set of SQL code that you want to execute. It could be some simple email sending code or something like that. When some sort of an insert, delete, and update occurs, that is what is called as a trigger. So what we are going to do is we are going to look at some codes, right? And we are going to create a trigger, execute the trigger, make some inserts, deletes, etc. into our database, and see what is the effect of it, and let's see whether our trigger fires or not. All right, welcome back. So we're going to look a little bit about, talk a little bit about triggers over here. And we just discussed that, what is the general concept of triggers? It's nothing but a set of statements that get automatically fired when some sort of an update, insert, or delete happens in your table. So, to kind of give you an overview, like when you open a table, all the triggers will be stored in this folder. So this is basically the GUI approach. And of course, you can right click and say new trigger. It will generate some code for you, and you can start writing, your trigger code. And again, if you actually go to view followed by template explorer, it'll actually open a set of scripts. And one of them I'm sure should be for triggers, where you can kind of create a trigger and then go to query and say specify values for template parameters, and then kind of update these values. So this is the typical thing that you could do when you are actually working with any feature, right? Any new concept. But what we'll do is we will actually write a trigger from scratch so that you get a feel of what this trigger is, how does this work, and so on and so forth. So let's just make sure that we have some room over here, and okay. So what I want to do is I want to first of all choose a table over here, and let's choose this one. Let's just look at some data in that table. Select star from human resources.shift. Okay, and let's just make sure we're using the right database. Let's try that one more time. And then it has just 4 rows, simple stuff. It has your shift name, your start time, end time, and when was that modified. So let's do one thing. You really don't want people to mess up shifts, right? Or accidentally some sort of new shift getting added without a management approval. So what we'll do is we'll create a trigger to not allow that. What we'll do is we'll say that whenever an insert is going to occur on this particular table, we'll just roll it back. Now, rolling back is a different concept. Just for now, think of it like you are not making those changes permanent, but you're saying that whatever statement was fired, please just make sure that that is not accounted for. All right. Okay, so the general syntax is, like we did for create view, it is create trigger followed by give any trigger name. I'm calling this as demo trigger. Okay, then you say on which table do you want this trigger. So I want this in my human resources dot shift, so I'll say on human resources dot shift, and then you can say after or before, and I'm choosing after. Again, insert or update or delete, right? I'm choosing insert. I'm going to say that as begin, first of all, print saying that insert is not allowed, you need approval, and then what I do is I just roll back the transaction. Very, very, very simple stuff. I use the end statement and say go. All right, let's see if this executes. So the command executed successfully. Now if I refresh this folder, I should see my trigger getting created, right? If I script this trigger, you will find that, this is the code that we had written. Okay, so it's time to test the trigger, right? We want to see whether this really works. So what I'm going to do is I am going to insert a row into this. So I'm going to say insert into this table. I'm going to use the general syntax for inserting it. So let's see what all columns we have. Shift ID is a primary key, so it's probably an auto incremental key. Name, start time, end time, and say modified date, right? And I'm going to put in some values, punch in some values. So I'm going to say values. Let's say I'll call the name as Rakesh, just the shift name as Rakesh, and it should basically let's just make sure we have some good values. So it starts at 7, ends at, let's not do 3, but ends at 8. Just trying to have some fun. I have a very short shift, and then I'm going to say that the modified date is today, right? Very happy if I get this shift, but when I run this, the trigger actually fired, right? It basically, oh, this is actually this is actually an error, right? This basically says that that the value already exists. So let's see. Okay, let's see. Let me just call this as Rakesh2, and let's see if this works. Okay, so you see that our print message got printed, and then what it did was it actually rolled back the transaction. Now if you run something like this, select star from our shift, you will not find a value called Rakesh2 that you inserted. The other conflict that we got was because I was trying out this and I might have inserted a value called Rakesh just to try out without triggers whether it gets inserted or not. But nevertheless, if you see, I tried to insert Rakesh2, but it actually rolled back the transaction completely. It didn't even allow me to insert that. So this statement was automatically fired. Now the interesting thing over here is this is at table level, right? You try to create something in the table and your set of statements got executed. What if you don't want to create a table level, but you want to run some statements when some sort of changes take place at the database level? Your database can contain so many tables. You don't want to keep writing triggers for every table, right? So that's what we call as a database level trigger. Okay, so the syntax is kind of the same. We say create trigger followed by your trigger name. I'll call it as db trigger, and then what I say is that on database, it's not table, but I say after I create any new table, what I want to do is I want to basically print a message saying that creation of new tables not allowed. It could be your any your any custom code, but I'm just keeping it simple and I'm rolling back the transaction, and followed by end go. And then now if I execute this and just let's just call this as db level trigger, just to make sure that we understand this. Command completed successfully. And now if I try to create a table over here, what will happen? Let's see, create table, say my demo table, and let's just have one column in it. The idea is just to show that what happens when a table is created. So our trigger fired and it didn't allow you to create the table. So this is really a very powerful thing in SQL, right? I have actually just given you a simple example, but just imagine the code that you can write in between these two, begin and end, can be for various complex stuff too, right? I have just printed out a statement, and as I said, we could maybe log, we would maybe send an email, we could do a lot of things, right? And this is where the concept of triggers really helps you a lot. Hope you enjoyed this. Please have a look at your assignments, quizzes, etc., and we'll cover some more interesting stuff in the coming lessons.
Welcome back. So in the last few sessions, we discussed about views, we discussed about triggers. Now it's time to introduce something new. Now, in this particular session, what we are going to do is we are going to talk about computed columns, right? So what are computed columns? As the name suggests, these columns are basically computed based on values of other columns. So let me give you an example. Suppose you have an employee table, right? And employee table is actually updated via some website. And what you do is this employee table contains a couple of columns. Contains the first name, and it contains the last name, and say some ID, say employee ID, and address, right? And what you want to do is you want to compute, or you want to actually derive the first name plus last name. Now, it wouldn't be really wise for you in the website or on the web page to kind of ask a form where you have the first name, then you have the last name, and then you say, give me your full name, right? Something like this, where it's nothing but your first name plus last name, right? And this is where we use the concept of computed columns. What we do is we add an additional column, but this column would be based on the inputs or values for the other columns. So what I'll say is this column is based on first name and last name. So I'll say this column is nothing but a concatenation of first name plus last name, right? So what you're doing is this particular column value, you are not asking from the user to directly input. Rather than that, you're actually computing. Now, one example I can give you is, I was working on a data science problem last week, where basically what I had to do is I had a table, right? And I basically had a couple of values here. And what I needed to do is against these values, I needed to compute the mean and I needed to compute the standard deviation, right? So it's a simple formula if you think about it. And accordingly, I was computing the mean and the standard deviation, by referring other tables and stuff like that. That's a different thing. But what I'm trying to say is that these are pure computations, right? Pure computations. So that is what these computed columns are. It's again very useful. in many of your situations. Let's quickly dive into how we can create a computed column in SQL Server.
All right. Now let's look at some code. So what we're going to do is, since this is a very simple concept, we're going to use a GUI based approach for now. But what we're going to do is we're going to create a table, and let me just call this as first name. Just two simple columns, right? We're going to exactly replicate what we just discussed in our previous session. Let this be varchar of 50, and I'm going to use the last name. All right, so these are simple stuff. But what I'm going to do is I am going to introduce a third column, and that's called as full name. But instead, what I'm going to do is I'm going to create this as a computed column. The way I can do it is, if you look at the properties, there is something called as computed column specification, and I'm going to just say that this is my first name plus, let me give a space, my last name, right? So what it's going to do is it's going to take the value in the first name column, the last name, and then it's just going to concatenate both of them. So simple stuff. So let me save this. I'll call this as my sample employee, and let's see how this looks like. All right, so the table is created. Once I refresh it, I should see my sample employee. Great. And I'm going to just add some values over here. So first name I'm going to put as Rakesh, last name as say G, and as soon as I commit this, you see that the full name is populated. It just took the first name plus last name, and then it just computed that. So as you can see, what I did was just a mere simple formula to derive the column values and insert it into a last column. So you can actually do much complex calculations as well, but the idea is that you really don't need to enter the third column, the value in the third column, but it is actually computed based on other columns. So simple stuff, but something to keep in mind. So in the coming lectures, we will look at further concepts as well. Thank you.
Hey, hello everyone, and welcome back. So in this session, we are going to introduce a very new concept that you will find using more often when you start developing your web applications or even reports. And this is a really very interesting concept, and you can see how the concept of stored procedures can make life really easy for you, clean up your thought process as to how to think in a more logical way, how to organize your queries and how to organize information in a more clear fashion. So let's start off looking at the Wikipedia definition. What does it say? A stored procedure is a subroutine available to applications that access a relational database system. A stored procedure, sometimes called as a proc, sproc, etc., is actually stored in the database data dictionary. So too many words. What we'll try to do is we will try to break this down, right? We'll try to kind of see conceptually what does this mean, and then using our usual approach, we'll write some code and see how does this look like in SQL Server. All right, so let's see. All right, so let's assume that we're talking about some kind of a website. Okay, let this be a shopping website. The typical websites where you can add some products to your shopping cart and then check out. So what do you really see in a website, right? First of all, there will be some sort of a facility where you can search for stuff, right? And let's assume that you search for shoes. Okay, so naturally you get a listing of shoes over here, okay, with your price. Now if you think about it, how does this happen? There's naturally a table, and I'm just simplifying this, which basically have your product ID,
product name, pricing, right, and stuff like this. And what it did is you basically just gotten this information and then displayed it in the website. Now, the way you can call this information or retrieve information is basically using a bunch of queries, select queries, right? You say from the product table, give me all the products, right? And this is what is basically we'll put inside a stored procedure. So what you will do is you will encapsulate these particular set of statements that you are going to use in something called as a stored procedure, right? And this stored procedure, you can call it anything, and I'm just calling it get all products. So whenever this application calls this stored procedure, get all products, there are some SQL statements stored inside the stored procedure that will get executed, and then it will actually retrieve the products and give it back to the website. Now, a variation. In this case, you actually searched for shoes. So naturally, from this products table, which may have thousands of products, you just want those products which basically are related to shoes, right? So I can basically write a parameter for this, right? And it's called as a parameterized stored procedure where I pass in the product name as the parameter. Okay, so what this will do is get all products where product name equal to shoes. So this is called as a parameterized stored procedures. So it will go to this table, run a select query along with the where clause, and where product name equal to, and whatever is that value comes from the website. Basically, you're passing a parameter to a table and then getting the results. This is called as a parameterized stored procedure. Now, another concept is we talked about inserts, right? We talked about selects, but a stored procedure can also be used to insert, update, delete data from your table. So what will be a situation where you will need to use that? So let's assume that, you know, we talk about the same shopping website, right? Where you search for shoes, and then you like a product, and then you say add to cart. So let's assume that all this activity is tracked. So when you add to cart, what it does is it'll say in a table Rakesh's cart, right? This table will have something like product ID, product name, maybe the quantity, and say price, something like this, right? It can have other stuff like date and stuff. We're not going too much into it. So as soon as you add to cart, what it does is it inserts a row over here saying that this person has chosen product 6, product name is something, right? Quantity is 1, and his price is say $19, right? Now what happens is when you go to your checkout page, you see that, oh, I actually need 2, quantity 2, right? So what I do is again update this, and then internally it calls a stored procedure which will update this and say the quantity is 2. So these are the, you know, simple ways in which stored procedures can be used. We saw how stored procedures are used to just select some rows. We saw how stored procedures are used to select particular rows, that is called as a parameterized stored procedures, right? And then similarly, we can extend that concept to insert rows, insert based on parameters, delete rows, edit rows, update rows, and so on and so forth. But think about stored procedures as, you know, your saved SQL statements that any application can call, and then you can retrieve the data. So what you're doing is, instead of actually writing a query every time, you have some expert who has written a very complex query for you and packaged it into a stored procedure, and you are just calling the stored procedure, right? Now, there could be many instances. For example, if you have a couple of reports, right? You're a report developer, and report is nothing but display of data, right? And let's assume that you need to display a data which basically involves foreign currency, and you want it to be translated to US dollars every time, right? You can either write code to translate it. You can, there might be a table or something which stores the conversions, where you can refer and get it. Or basically you can have all those logic embedded in your stored procedure. So when you actually make a call to the stored procedure, it retrieves the data, converts the data, and gives you the converted data, right? So for you, this is kind of a black box, but what you have done is actually written your solid logic. You have encapsulated it, and more or less you're saying it's reusable, right? And one of the most important things over here to remember is, when you have stored procedures, you can centralize the logic according to whatever rules you want, right? Like for example, if you have people inserting data into your table, it's very difficult to say that whenever you insert, make an entry into the log table, or whenever you insert, check for this, but instead you can have one person actually write the logic and just tell everyone that if you ever want to insert a row over here, this is the stored procedure you have to call. And that stored procedure, you can have checks and all those things with parameters, where you can either return an error message saying that the data that you have passed is corrupted or is not correct, or it cannot have a negative value, things like that, or it can give you it can actually insert the rows. So again, it's a very interesting concept. More or less, when you start accessing these tables, you will find that you will start using stored procedures a lot, either be a report development or an application development, and so on and so forth. So let's go ahead and look at some code and walk through some examples. Thank you. All right, welcome back. So here what we're going to do is we're going to run through some actual examples and start creating some stored procedures. So what we talked about is stored procedures is nothing but a set of SQL statements or basic objects that are stored in your database, right? Now, one of the things to remember is stored procedures. When you actually create a stored procedure, you can actually, it actually compiles and an execution plan is created, right? We will go through more in details of how the execution plan is created and what is an execution plan and all. But now you can remember that just take my word on this, that it will be cached, and hence, it will be a little bit faster. And of course, you can have separate execute rights on stored procedures. You don't really want everyone to start accessing your stored procedure and inserting data, editing data, but it may be okay for them to just call stored procedures which run some select statements, right? So you can really give separate rights to your stored procedures as well. Then we also talked about how your applications or reports, etc., can call your stored procedures. Now, regardless of we create stored procedures or not, SQL also has its own inbuilt stored procedures, right? If you go to the model database, go to programmability and stored procedures, this is where all your stored procedures are stored within the database. You will actually find a lot of system stored procedures. These are all created by SQL. When you install SQL, all these stored procedures are, you will see them in your particular installation. So let's get started. Okay, let's go to our AdventureWorks. This is where your stored procedure is stored. AdventureWorks also has a lot of inbuilt stored procedures. Let's go ahead and create a stored procedure using the GUI method. The way you do that is basically just right click, say stored procedure, and it kind of creates a template for you, right? Again, don't worry too much about it. We'll write from scratch. The other thing is, again, as I've been showing you before, is go to view and say, let's see where it is. It's called Template Explorer, and it will open up a set of stored default templates, and you can see that there are a lot of templates created for you. Double click on something and that'll kind of open up a template for you. Go to query, go to let's see, specify values for parameters. You can specify all these parameters, click OK, and it'll actually fill up the template values for you. Now these all look good, but what we really want is actually to write a stored procedure from scratch, right? So let's do that. Let me make some space here.
Let me make sure I close these things. All right. So we are going to talk about stored procedures. Let's see. Now, when we created views, triggers, we followed a common syntax called create a view, create a trigger, etc. We are going to do the same thing now. We're going to create a procedure called my test, let's say, yeah, my test proc, okay, as set no count on. Now, don't worry too much about this one. In a minute or so, this will be super clear on what a set no count on. And I'm going to say select star from, let's see what table we have. All right, let's use the same one. Let's use the same one that we used in the previous example. Yeah, that should be it. And let's just make sure I'm referring to the correct database. Once I execute this, the execution completed successfully. Now, if I scroll down to my stored procedures and refresh this, you will find that my test proc is over here. If you right click on this and say modify, you will actually find my code here, right? So you have created the stored procedure. Now anyone can call the stored procedure. How do you call the stored procedure? It's very simple. You say execute my test proc and you get the results. So all a person will need to know is your stored procedure name, right? You can say that your application, if you want to get all the shifts, just call my test proc from whatever applications you need. I have granted everyone select rights over this, and you will get the results, right? So this is basically the way how you can call. But if you look at messages, you see that there is a SQL message returned to you saying commands completed successfully. Just keep this in mind. We will see a small variation, right? Now let me go ahead and create another stored procedure. Basically, I'll use the same thing, but I'm going to call this as my test proc 2. And here I'm going to use set no count off. Same stuff, but just a small variation. Command completed. I'm going to say execute my test proc 2. The results will be the same because it's the same select query. But now if you go to messages, you see that there is 4 rows affected. So that's what precisely this gives, the no count on and off. It'll just give you how many rows were affected, and if you don't want that message to be shown, that's where you set it on or off accordingly, right? That's the very simple difference. All right, let's move forward. And actually, I wanted to also show you one small thing. You can also execute it this way: exec followed by your procedure name. So execute, exec, and all, the same things. Let's go ahead and drop my procedure. Just to show you how stored procedures can be dropped. My test proc and then my test proc 1 or proc 2. I hope this works. Let's see. Okay. Okay, I basically misspelled this. It's called my test proc and my test proc 2. Hopefully this should work. All right. So we have dropped our procedures. Now we talked about parameterized stored procedures, right? So how do you really create a parameterized stored procedure? The basic syntax is the same. You start with create procedure, my first parameterized procedure. Let's give it some simple name, and I'm going to say that parameter name. And you can give this any name. You can call this as product name, anything, right? In our case, it was product name. So I'm just keeping it very simple. And the parameter that I'm going to be passed is going to be a varchar. And as I'm going to set the no count on. And by the way, all the no count on and all these are optional. But I'm just, it's a good practice. So select star from, let's use the same thing. Let's use the same table because it just has 4 rows. So it's simple to visualize. Where let's go ahead and just look at what this table has. So we'll say where name, let's pass name as a parameter, right? So we'll say that where name like
or name equal to say parameter name. So what you're saying is the name will be passed via your application, and accordingly it will pass it into the where clause. Let's go ahead and create the stored procedure. Oh, there is already a stored. Okay, let's call this stored procedure. All right, so our stored procedure name is called as my first param procedure, and let's go ahead and call it. Let's see how we can call it. So exec or execute my first param stored procedure, and then you can say that my parameter name equal to let's say day. Let's see if this works. Sure enough, it just filtered the data, and it's kind of just showing you the day shift. Now another variation is you can also call the stored procedure this way without actually mentioning this. You can call it this way, it will give you the same result. But one thing to note here is we have just had this example with one parameter. You can have multiple parameters as well. In that case, it's really very essential that the ordering of these values are super important. For example, you have a parameter name as your first parameter, parameter name 2 as your second parameter. You need to make sure that the values are passed in the same order. Okay, now let's try something else. Let's say if I just pass in without any parameters, what happens? Well, it gives me an error. It says that parameter name was not supplied. Now, this is really not a good way of programming, right? I mean, people can make mistakes, right? They might actually fail to pass parameters. So your code should be good in handling those kind of situations. So let's go ahead and do something in which we can avoid this error, right? So I'm going to drop this procedure, and of course you can also use alter statement, but I'm going to just drop this procedure, and what I'm going to do is I am going to recreate the same thing but slightly differently now, right? What I'm going to say is I'm going to put an equal to and a value. What this says is if the parameter name is not passed by the user, use the default value called evening, right? Now you can customize this however you want, but the whole idea is to show you how can you pass a default parameter if the customer fails to pass a parameter. Let's go ahead and create this, and let's go ahead and execute this. My first param procedure, and it'll give you the evening data, right? I didn't pass any data, so it's giving me a evening data. But what if I pass one parameter as day? It'll give me the day data, right? So this is how you can actually play around with parameters and default values. We never talked about output parameters, right? It's a very interesting concept as well. Let's look at how to use an output parameter in your particular stored procedure, right? Output parameter is nothing but you store the results into a parameter, and you output the parameter, and then you access the value from that particular output. Let's look at it, it'll be more clear. So again, very simple. Let's create a stored procedure. Let's call this as my output SP stored procedure, and let's see, let's just create something very simple. Let's create something called as top shift, and this can be a varchar, right? But I do not want this value from user. What I'm saying is this will be your output parameter, hence I have actually suffixed with the keyword called output, and then I'm saying set my top shift value equal to, and just a simple step, select top one from select top one shift, actually select top one shift ID from what was the table name. This was the table name. It's from this one. Okay, and yeah, that's pretty much it. Let's see if this works. Oh, some issue. Oh, okay, I didn't close the bracket. I hope this works this time. Okay, so we have a procedure with an output parameter, but once I execute this procedure, how do I get the results? Let's look at it. So I'm going to say declare my output result, just creating a parameter called output, or creating a variable called output result, back arrow 50, and I say I'm going to execute this particular stored procedure that I created, and in turn what it is going to do is it's going to give me the result but in a particular parameter or in a particular variable, and this is the variable I just used, output result, and this is going to be type output, right? And then if I just select from this output result, you will get the value, just a top one, right? So the ways that you can use this is sometimes you make some computation using stored procedures, you store it in a value, and you have to reuse the value, reuse the whatever is returned from stored procedures in some other logic, right? And that's where you can really make use of these kind of output parameters and stuff, right? So let me go ahead and drop this stored procedure. Okay, let's see, drop proc this. All right, now we looked at how to execute some select query from stored procedures. We looked at how to use parameterized stored procedures. We looked at how to use output parameters, but I wanted to show you something else. What if you want stored procedures to do something and return a value, right? Basically returning values from stored procedures, and that's also very interesting. Let's have a look at it so that you can appreciate the idea more better. All right, procedures, and then the overall process is simple. You start with create proc, and you say my first returning SP, stored procedures, right? And you say return 12. You see that this is actually an integer number I have actually used here, and if I actually execute this, I can use this as declare my return value. Any variable name you can give, can be an integer, because my return value is an integer, and I'm going to execute this stored procedure. But what it is going to do is it's actually going to return a value, so I need to capture this value in this particular variable that I created, and then I'm going to select that value. So simple stuff, it returned 12. Now you could basically use this to do some logic in your stored procedure and maybe return a status, right? Success, failure, 0, 1, 2, 3. You really don't want the values to be returned as such, but for example, right, you might want to have your application call a stored procedure and perform some checks, right? You don't really want to pass in the values, but it could be as simple as, does this user ID and password exist? Your return variable can be 1 or 0, right? Your return value can be 1 or 0. So you really don't need to pass something that is stored in the database. Rather, what you're doing is you are having your own logic and mainly just returning some sort of a status. So very interesting concept. Lot of varieties here: parameterized, non-parameterized, output variable, return variable, and so on and so forth. And I believe when you start developing your reports or your applications, you can really find some use for each of these types of or varieties of stored procedures that we just discussed. And I hope you'll enjoy playing around with this. Also, feel free to look at the quizzes. It'll give you more information and on how different things work together. And I hope you like this particular session. Thank you. Hey, welcome back, and hope you enjoyed the last session where we took a very deep dive into stored procedures, and we looked at how to call stored procedures, what is the overall concept of stored procedures, what is its practical use, what is meant by a parameterized stored procedure, what is an output parameter, and so on and so forth. So now I thought it's probably the best time to bring in a new concept, and that is very much similar to the concept of stored procedures. We call it the user-defined functions, or it's also called as UDF. Now, if we look at the MSDN definition of a user-defined functions, it says that, like functions in programming languages, SQL Server user-defined functions are routines that accept parameters, perform an action such as a complex calculation, and turn the result of that action as a value. The return value can either be a single scalar value or a result set. Now, one common thing that can come to your mind is, well, this is similar to our stored procedures, right? So what really is the difference here? Well, I agree with you. There is a lot of similarities, but user-defined functions can also be called inline. If you are used to some programming languages where you create methods or functions, you will appreciate this concept a little bit more. But to kind of give a overview of as an example, right? Suppose you want to do certain tasks inside a query itself, right? You want to pass in a set of parameters in your where clause. How can you do that? You basically define say a parameter, right? And then you kind of pass in that variable to the where clause. But what if that variable requires some massaging, right? For example, what if the parameter sends a comma separated list and you want to kind of split that? You can actually have a separate logic and put it into this user defined function and pass that comma separated list as a parameter to that function which returns a set of values. This might be getting too complicated since there is nothing to visualize here, but let me promise you that we will look at some examples where you will be able to relate to what is a user-defined function and how does it really differ a little bit from a stored procedure. All right, so if we proceed next, we see that there are three types of functions. Again, we will walk through an example, but just to understand the overall concept of this. One is a scalar function, right? It will just return a single value. You execute the function and in return it's going to give you a single value. The second is a table valued function, right? So you execute some code and in turn that function returns a table. Now this is what I said, a comma separated list. You pass in a string of comma separated values and in return what it does is it gives you a table with those values, each value in one row, right? So again, when we start looking at examples, you will know what this is. Then there are a lot of system functions as well. Then naturally it cannot be modified, but you can take advantage of a lot of system functions to get a lot of information. For example, if you remember, we have used the getDate functions in many of our previous examples. GetDate is something that the system provides. You just call the function and it returns the value inline. That's the best example of how you can visualize a user-defined function and how it really differs from a stored procedure. So these are some of the user-defined system functions. You can look at MSDN as well to get more information on this, but I just want you to be aware that there are a lot of system functions that are provided, that are inbuilt, and that you cannot modify. So I hope you've got a little bit of idea of what a user-defined function is. If not, don't worry. When we look at some examples, you would be able to appreciate more about the concepts of a user-defined function, and then you can really see what is it and how is it different from a stored procedure. All right, welcome back. So we just discussed what is a user-defined function. We looked at the theoretical aspect of it just to get a understanding of what a user-defined function is and how does it compare with stored procedures. We looked at scalar, we looked at table valued, and as well as we looked at some system functions as well. My whole goal of this particular session is to show you some examples so that you can better understand how does this differ from stored procedures. So let's start with something simple as we've been doing so far, user-defined functions. All right. So let's go ahead and look at some data, right? We need some data to play around with. So I'm going to use my sales territory. So select star from sales territory, and it has a bunch of rows in it. Okay. So what I'm going to do is I am going to, let's say, just select a sum of this, right? So let's look at a scalar based scalar return value of a user-defined function. So like we have done before, like create view, create trigger, create stored procedure, naturally you must have guessed it by now. It's going to be create function followed by the function name. So it's YTD sales, and we use the open and closed parentheses. There's nothing inside these parentheses right now because we are not passing in parameters. We'll look at one more example where we pass in some parameters as well. Next, we want to give a return data type, and we say that it's going to return money, right? And then we just start our statements. As begin, let me just quickly declare a variable. Declare YTD sales as money. Just make sure that I spell this correctly. Okay. And then select my YTD sales equal to, let's say, sum of this particular column. So sum of sales YTD from this table. Simple stuff. Returns one value. And I'm going to say return my variable, whatever is stored in that variable. End. All right, let's see if this works. All right, it executed fine. Now, let me show you something. If I go to my functions, refresh this, and go to my scalar valued function, you see that there is a new function created here, and this is the function I just created. You can modify that and look at the code. It will be the same code that we just wrote. All right, so let's go ahead and execute this function. So how do I execute this? First of all, I need to declare a variable, and I will just call it as YTD results, just keeping it intuitive. And this is going to be of type money. And then I'm going to say select into my YTD results, and let me just call the function that I just created, YTD sales. And then I'm going to just print this out. Very simple stuff. So you see that it returned a scalar value, right? Now, this is the simplest of the functions, and then now you can really see that in between a query inline you have actually called this, right? You can have a very complex query, and then in between the query you can call this and use that value and so on and so forth. Now let us just play around a little bit with parameterized functions so that you get a feel of that as well. All right. So the logic remains the same. So let us just make sure that we are super clear on what data we are dealing with. So, all right. So we are dealing with sales territory data, and let's do something different here. Let's pass in the group as a parameter, and accordingly it will give the sales YTD. It will still return a scalar value, but what we are doing right now is it's not summing up this entire column, but rather just filtering by whatever parameter we are sending. So let's go ahead and create a function. So create function. Let me make sure that I have some room. Okay. And let me call this as YTD group. Just to make sure I clean up things correctly, I'll just use drop function YTD sales, just to make sure that when I execute this the next time I do not encounter a conflict. Okay, create function YTD group, and this time it's not going to be just open and close parentheses, but what I'm going to do is I'm going to introduce a parameter, and I'm going to say the type is varchar of 50, and I'm going to say it returns money, right, as begin, and I'm going to say declare YTD sales as money. Okay, what I'm going to do is inside this variable that I just declared, I'm going to select the sum of sales YTD. Just so that you can visualize what I'm talking about, let me just show you the data. So sum of sales YTD, again from this table. But what I'm going to do right now is I'm going to introduce a where clause, where group equal to whatever is sent here, YTD, whatever is sent as a parameter here, group. Right, so simple stuff. So once this computes, then we say return whatever is YTD sales. And let's see if this compiles. All right, this worked. And then let's go ahead and just run this. I'm going to say declare results as money, and I'm going to say select results equal to dbo.ytd group, and now I'm going to pass in North America, right? Let's go ahead and print the results and see if this worked. All right, so this did work. So let's try with some other parameter. Let's pass in Europe. Okay, so this is how you can pass parameters to your functions as well. Now we talked about your result set being a table, right? Basically functions returning tables. So let us look at an example as well. All right, so just to make sure I clean this, drop function YTD group. All right, okay, so let's go ahead and create a function. This is just a small variation to our existing one. So st_tb valued, table valued function, and let me show you with a parameter. So territory ID I'm passing as a parameter, again just so that you can visualize what I'm talking about. Let me just show you. So I'm just passing this particular ID as a parameter, and this is an integer. I close the brackets, and then I say it returns a table this time. And by now you must have guessed the syntax as return select name. What else can we select? Country, region code. We have group. Let's select sales by TD also from this. So just 4 columns. Let me make sure I put this in square brackets. From sales.sales territory, where territory ID equal to whatever is passed in, right? So let's see if this compiles. It did. Now how do I call this? So I'll say select, you can say star from, directly call that function, table valued function. It was st_table valued or tab valued, and you pass in a parameter, and I'm passing 7, and it returned France. And at the same time, if you just want certain fields to be returned, you can say country, group, name and group, and it will return only that portion of what you're asking for. So we looked at all the varieties here. We looked at how to get a scalar valued function, how to get a table returned back, how to pass in parameters, and a combination of all of them. So by now you must have really able to differentiate between stored procedure and a user defined function. I would strongly encourage you to go through some of the exercises that I will be uploading, so that you get a better feel of how these things are and what are the different things possible over here. User defined functions are really powerful functions. Even in a lot of mathematical operations that you do, there are lots of libraries which will actually give you a bunch of user defined functions that will allow you to do certain complex calculations, and you don't really need to start writing complex code for that. So that's kind of the overview of user defined functions. Hope you enjoyed it. We will see you back in the next session. Thank you. All right, welcome back. So we are almost midway in our course, and I think it's the best time to go into more and more complex stuff, so that when you start designing your applications, you at least know what is out there and how you could use them. So this is a good time to introduce the concept of transactions and error handling. But before we take a deep dive into those concepts, I believe we should first look at some fundamental database concepts that will help you understand the code when we start writing it, and when we start looking at some examples. Okay, what are transactions? if you look at a typical Wikipedia definition, that's what we've been doing so far, is basically transaction is a single unit of work. If a transaction is successful, all the data modifications made during the transaction are committed. Committed meaning it is stored in the database. But if it fails, whatever you did is basically rolled back, right? So it's basically saying that a database should always be consistent. In the sense, if you're doing some mathematical operations, you store the data only when all the operations actually completed. If there was some error like division by 0 or something, you don't really store the partial result, but your code should be intelligent enough to roll back the transaction and say that something like this never happened, right? So only then you will be able to trust the database, right? Whatever data is in your database should be trustworthy, and transactions help us do that. So for that, there is basically something called as ACID properties. If you read it up, and typically ACID means atomicity, consistency, isolation, and durability. These are the minimum set of properties, right, that guarantee that database transactions are processed reliably. Now, in databases, right, when we write code or when we have certain operations, each logical operation is what we call as a transaction. So when I say commit transaction, it basically means that whatever logical steps we just did, we are actually making it permanent in the database. When I say roll back a transaction, again, whatever logical steps we just did, we are just undoing those things or undo those things, right? So let's look at ACID properties. A stands for atomicity. It's basically saying that whatever transactions you write should be all or nothing, right? Meaning the transaction should be completely successful, or if there is an error, you start rolling it back, right? So that is basically what the atomicity property in the ACID properties tells us. The next one is consistency. Consistency basically says that any transaction will bring the database from one valid state to another. So if you think about it, when you actually start making changes to data, you are actually saying that the database had this data. Now after your set of statements, it is going to have this data, right? So it's basically just saying that whatever executions that you do, whatever logical statements that you execute will always be making the database consistent or keeping the database in a consistent state. Isolation property ensures that the concurrent execution of transactions result in a system state that would be obtained if transactions were executed serially. For example, if a table is being updated, or let's take an even simpler example, if a row is being updated and the updates happen parallelly, right? One user updates the row, second user also updates the same row, you shouldn't really have inconsistent data. The database should provide sufficient mechanisms in which all these updates run as though they are updating in serial order, right? So we won't be going too much in locking a row, locking a database, locking a table and stuff. But if you want to read it up, you can read up the concept of locks, how an exclusive lock is placed, how a row level lock is placed. That will basically make sure that this particular property has been fulfilled. The last is durability. Durability meaning once you store your data, it should remain in the database, right? Imagine you shut off your computer and then you shut it on the next day and all the data is erased. That cannot be true. It should always be persistent, and that's what is the concept of durability. So these are the 4 basic principles around which databases are built. So let's take a deeper dive on these things theoretically, and then we will look at some code as well, right? How these ACID properties come into existence, how do transactions work, what do you really do if an error occurs, what is rolling back a transaction, what is committing a transaction, and so on and so forth. All right, so before we start writing some code, let's try to understand how transactions are important and why error handling is important, right? So let's just look at a typical example. You have your account in some bank, right? Bank 1. And you have your whatever savings account or something like this. What you want to do is you want to transfer some money to bank 2 to your friend's savings account, right? So you want to transfer some money. Typically, if you think about it, how this happens, one is it debits this amount from your account, right? And then next it credits the amount to your second account or bank 2 account. Now if you think about this at a very high level, this involves 2 steps, debit and credit. What happens if your logic fails after step 1? After step 1 is completely succeeded, but step 2 fails. That means your money has been debited, but at the same time the money is not credited in bank 2, right? Or you can have other failures as well, right? Something happened during your debit, but the money was successfully credited in bank 2, so the debit amount does not even show up in your account. So this will be a huge disaster, right? So basically what you're saying that only execute if my steps 1 and 2 are able to succeed completely. Even if there is a failure anywhere, you start rolling back or start undoing everything that you did. And that's basically is the concept of rollback, right? But if both of them succeed correctly according to some criteria, you basically make the changes permanent. That is called as committing a transaction. Commit transaction. Right? These steps are your logical steps. These steps are your transaction steps, right? But at the same time, you can have instances where you have taken care of rollback and commit. You are taken care that both of these accounts will always have consistent data, but you want to have some sort of logging mechanism or error messages, right? When this happens, that is where the concept of error handling comes into play, right? You use something called as try catch. What you do is whatever is the logic here, you put it in the try statement. Try statement just means that try executing these SQL statements, right? And if there is any error, the control is transferred to this block or the catch block. And this is where you can have your error handling code. What do you need to do? Do you need to escalate this? What is the severity of the error, right? Do you need to send an email? Do you need to inform someone? Something like that. So this process of putting things in try, executing, and then transferring the control to another set of statements which you can write basically gives you complete control over error handling. You can really write your custom error, very specific way of handling errors in a more nicer way and not really depend just on what the system will give you, right? So the concept of try catch is widely used. One of the examples that I can give you is in one of the projects that I've been working is basically the upstream is set up in a way that is having log shipping, right? So it restores the database maybe every 4 hours, 5 hours kind of a thing, right? So naturally, when I query the database, if it is during that time of restore, it is going to throw an error. Now, if I don't encapsulate it in the try catch, it will actually throw that error to the application itself, right? But what I want is, I want to check if the error is basically something got to do with restoring, right? I put that logic. If the error is something to do with restoring, wait for maybe 15 minutes and retry, right? So I can have that kind of logic over here in the catch statement. Catch statement is just saying that I will give you the control, whatever, I will execute the lines of code in your catch statement, catch block, if at all I encounter an error. And so you handle it however you want. If you don't use a try and catch, what it will do is it will just throw the error to the calling application, right? So if your calling application can be as simple as calling the stored procedure, you can write an execute statement followed by a stored procedure name and call these lines of code, and the set of errors will come here, right? So it depends on how you are planning to design it. So let's go ahead and look at some code. All right, so we looked at some theoretical concepts of what are ACID properties, what are transactions, how to handle error, and what is committing a transaction, what is rolling back a transaction. So I think by now theoretically you know what we are talking about. We are just saying that whatever logic we are writing, there are mechanisms to ensure that if some issues happen, if some errors happen, we can always undo it, right? So I think the concepts will be more clear when we start writing some code. So transactions. Okay, so let's go ahead and query our typical table which we have been using, sales territory table, right? I'm just trying to use a table that has minimum number of rows, so that it's we don't really focus on the data and stuff, and you don't have to jump around with lots of rows and stuff like that. So let's go ahead and oops, I don't know what the issue is, but let me try that again. Okay, and let me just make sure that it's adventure works. All right, so we have some data now, and just to make sure that I use a grid, let me execute this again. And okay, this is a typical way of looking at our data. All right, so let us start with something super simple, as we always do. Let us begin a transaction, right? I'm going to update the sales table, sales territory table. And what I'm going to do is I'm going to set the cost YTD, basically this particular column, equal to $1, where territory ID equal to 1, and commit transaction. So basically I'm saying that I'm executing this in a transaction, and then if everything succeeds, just go ahead and make it permanent. I don't think there should be any errors happening here, so it made it permanent. Now if we query our table, you see that the cost YTD is $1 for territory 1, right? But this is a very simple thing, right? Now let's look at something which will actually give us an error as well. Okay, so before we go there, I would like to introduce you to some error variables which will give you some error numbers. Now @ error is inbuilt, right? What it will do is it will give you the error number of the last executed statement, right? 0 means success, 0 means nothing went wrong. Greater than 0 means error. I think it's greater than 0. Basically non-zero means error, right? So what we're going to do is we're going to execute a couple of statements, and then we are going to look at the error number of that. If error number is 0, that means all the statements succeeded. But if it's greater than 0, that means some error occurred, and that is where we are going to do stuff like either maybe put it in catch statement or maybe rollback. Let's see what we can do. So let's approach it this way. Let me go ahead and just declare a variable. Let me call this as error results. Okay, as varchar of 50. All right, so what else can we do? Let's begin a transaction. Begin transaction. And then what I'm going to do is insert into, let's insert a row into the sales territory table, right? And let's say sales territory, I like to generate the script this way. Then I can just copy this, go back, and then, just substitute the values. So I'm going to say name as, say, ABC, country region code as US, okay, group as, let's see, NA, North America, sales as 1.00, this as 1.00, cost as 1.00, cost last year as 1.00. I hope I'm using the, okay, and then there's a row GUID. So I'm going to just make sure that I use the correct format. So I'll just change a number or something. Okay, and then the modified date. Let's use of some system inbuilt function that we talked about. Okay, so we are going to insert a row. Good enough. Then what do we do? So basically we are saying that let's check our error variable. So if error is equal to 0, that means our stuff actually succeeded, right? So we have to write some code for that. So what I'm saying is, if error results equal to 0, then I don't have to worry, my statement was successful. So I'm going to say print success, and then I'm going to commit the transaction. But what if the statement didn't succeed? That is, if the error result is greater than 0, right? So what I'll do is else begin, print statement failed, and then we'll say roll back my transaction. And I think that's it. I should end. Okay, so we do have sufficient logic checks here. So let's see if this succeeds. Incorrect syntax near keyword else. Let's see, what did we do? If error results equal to 0, begin, I need to spell this correctly. Okay, let's try this one more time. Okay, it succeeded, right? It inserted the row, it succeeded. Now let's try doing that one more time. Now it's getting a primary key conflict. So what it did was that the first time it entered this block because my error code was 0. The next time the statement threw an error, so the error code was not 0, so it entered this particular block and the statement has been terminated. Basically we rolled back the transaction. Now if you actually look at our table, let's just get a select statement somewhere. Yes, from here. Now if you select from this table, you will only find one entry for this, not two entries, right? We actually rolled back the transaction. So that is basically the whole point of, the whole idea of rolling back a transaction. Now let me show you something about a custom error message. Many times your applications call your code, your stored procedures, and you want to handle errors and give them some more information or custom error messages which they can use to debug. So what we're going to do is we're going to use the same set of code, just to make sure that we save some time. We're going to use the same code, but what we're going to do is we are going to, instead of just saying print statement failed, we are going to use something called as a raise error. This is an inbuilt function where it accepts 3 parameters, and I'm going to say statement failed, and then you give the severity and priority as well, and you can get more information on this. Don't worry about this too much. So you basically raising an error and passing a custom message, right? This is my custom message, and this is what is passed on to your calling application. Now if I execute this, you see that your custom, so the first red line is basically the system generated message, right? The second one is actually a custom message that you created right now, right? So your calling application gets enough information as to, it can know, what the error is. A third way to look at it is what we discussed as try and catch, right? We said that we can put a bunch of statements in a try block. If it basically fails, the logic transfers to the catch block and you can handle it there. So the advantage of this is, now, some people ask me, why not just use if and else like you just showed me? The problem of if and else is you actually, this is an error that is being shown to the UI, right? It is actually thrown as an error. In try catch, you can actually handle that error and not let the user know that the error has occurred, right? You can do some login, roll it back and stuff like that. In short, your execution need not be really breaking the control, right? You have a set of statements, you can keep putting try catch, right? But not really break the whole flow because an error occurred. If you know how to handle the error, you can handle the error. There could be many arguments like, we should never handle the error, we should always throw the error and stuff like that. But, I'm just keeping it simple for now. All right, how do we do this? Begin try, and then I begin a transaction, and then I say declare error results. Let me actually copy this code. Okay. And begin transaction, this one, and then we can say that commit transaction if this succeeds. All right, and then we say end try. Then I need to have a separate block for error handling. Begin catch. What do I do? Print catch statement entered, something so that you know what it is. And then I just roll back the transaction. So basically what I'm saying is, if an error occurs, don't really throw it as an error, just roll it back and stay quiet. So let's see if this works. All right, so you see there is no error over here, but you actually handled the error. The catch statement was entered and you actually handled the error. So these are the varieties of things that you would commonly come across, right? You will need to use transactions a lot, try catch statements a lot, and stuff like that. So it is essential that you know what these things are, what are the possibilities out there, right? You will come across terms like deadlocks and how to handle deadlocks. Deadlocks is nothing but if two people are trying to access a set of resources, if one is waiting for second and second is waiting for the first, then basically you start waiting infinitely, right? Just waiting for the second resource to release and so on and so forth. So there are deadlock resolving mechanisms that SQL provides. There is something called as a deadlock graph, which will actually tell you who the victim is and stuff like that, or which process is causing the deadlocks and stuff. We won't be getting too much into it, but I just want to make sure that you are aware of these things, so that you if such an error occurs, you at least know where to go. Hope you enjoyed this concept of transactions and error handling, and please feel free to go through the quiz and assignments and ask questions in the discussions forums as well. Thank you. Hello everyone. So we are back again with a new concept, and as we are going towards the end, I thought this is the right time to introduce common table expressions and grouping sets. Now, many times when you start writing queries, you often find that is there an easier way to temporarily store some result set? Meaning you do some computation, you have a table you are dealing with, and basically you want to temporarily store that particular set of values in order to do further computation, right? One of the things where we saw was that when we discussed user-defined functions, we returned a table, right? So we looked at a table variable as such. So similarly, if you have a set of queries where you want to just temporarily within your session store that table but not persist, that is where common table expressions, or commonly called as CTEs, come into picture. Let's look at a few code examples as to how CTEs play. All right, so common table expressions, or CTE, start with the with keyword, and then you can give any name to it. I'm just calling it as CTE underscore say sales territory, right? Because that's what we have been dealing with so far. And just to make sure that you can visualize this, let me just go to the sales territory table. It should be somewhere. Okay, let's copy this All right, let's just quickly look at the table first. Okay, this is the table we are dealing with. So with CTE sales territory as, and then we given the query which basically we want to temporarily store. So I'm going to say select name and country region code from sales.sales territory, right? So whatever is returned from this query is actually stored temporarily in CTE underscore sales territory, right? So how do you access this? Well, you can actually write a query select star from CTE underscore sales territory where name like, let's say, Northwest, right? And just remember you need to end with a semicolon, and let's see how this works. All right, so you saw that temporarily this is how you store your result set. You can actually use this for self recursive and so on and so forth. So this is something very interesting to know, and it's oftentimes very helpful to kind of break down your very complex things, because if you're going to write a very complex query, you might as well break it down and put it into common table expressions, and then join all the common table expressions to get the result set that you want. That's kind of the personal approach that I follow. I try not to write a very complex query. I try to break it down and then use common table expressions or temporary tables and stuff like that in order to proceed further. So simple concept, but very useful and very helpful. The next thing I wanted to introduce is called as grouping sets, right? So before I kind of deep dive into it, let's take a revision of our group by clause, right? So let's take our sales territory table and let's look at this, right? Simple stuff. So your boss comes to you and says that, okay, give me all the names, right, and a sum of sales YTD, right? So this is a very simple query you will write. You'll say, all right, no problem, select name comma sum of sales YTD from this table, group by name, right? Your boss is very happy because he has got the results that he wanted. Now basically he comes back to you and says that, you know what, can you actually give me name and country region code followed by the sum of sales YTD? He said, okay, no problem. And then you go ahead and modify this query and you say that, okay, let me just include country region code, and this should work. Terrific. So you're happy, your boss is happy, he's getting what he needs. He comes back to you and says that, you know what, I'm sorry, but I have one more change request. Can you also include the group here? This one, this group. Now it's kind of getting a bit irritating, right? You've been making changes all along, right? And every time you need to go and change the code, it's just getting more irritating now. But it's your job, and then you go ahead and make this change. Everyone is happy. Then he comes back to you again and says that, you know what, give me a combination of all three. I'd like to see all the three groupings together. And you're like, well, that's basically not possible, but let me try. Let me do something like union all and union all and execute this, and I'm just hoping that this won't error out, but unfortunately this gives an error saying that you need to match all the columns, right? You see that the third query has 4 columns, second query has 3 columns, and first query has 1 column. Your column numbers, column data type should exactly match. So what I'm going to do is I'm going to introduce a null here, and I'm going to introduce 2 nulls here so that the columns match. All right, so you were asked to do something, you did it. Now what? Now your boss comes back to you and says that, oh wow, this is really good. I have one more table that has 200 columns in it. Can you do the same thing? And you're like, no, because it's a really tedious task to start going through each of them, figuring out combinations and stuff like that. And that's why we'll be using something called as grouping sets. What we are going to do is we're going to rewrite the same query but slightly differently. What I'm going to do is I am going to say grouping sets, and I am going to give it some set values. So first group by name, right? And then group by name, comma, country region code. All right, comma, and then group by name, country region code, and group. Perfect. Let's see if this works. Shorter query, no union, nothing, but it just figured things out. All right, now basically what we have done is we have actually gone ahead and defined all the groups, right? This is the superset. Then we dropped one column, then we dropped two columns. We have actually defined here too, you have to define all the groups. Is there an easier way? Yes, and that's where we introduce the roll-up clause. So roll-up is something similar, and what we do is we kind of give the superset here, right? And it automatically keeps dropping the column. So this actually translates, oh, just one second, I need to use the roll-up clause here. Yep. And this actually translates to, this group translates to something like this, right? So 3, 2, 1. It keeps dropping a column from your superset. Let's execute this. So same thing. Okay, now what if you want to find combinations, right? You have these. You need to find, you need to group by name and country region code, then name and group, then country region code and group, something like that, right? All combinations. And that's where we introduce another concept called as cube. So it's, by now you might have figured out, it's pretty much the same concept. What we do is we group by cube, and the rest of the things remain the same, right? So very interesting stuff, right? When you are especially dealing with a lot of analytical stuff and you need to find averages, sums based on different combinations, you need to be really, really diligent. If you are going to write so many group by clauses and union them, there could be errors, and especially this becomes really, really, really difficult when you have huge number of columns, and that's a very practical thing, right? If you're going to generate reports, there is going to be minimum 10 to 15 columns, and you would need to have averages, sums based on different grouping criteria. And mastering this concept is really going to help you, and it's really going to make these things very simple for you. So this is something I found very interesting. Hope you also find it very interesting. And then we'll come up with more interesting stuff in the coming sessions as well. Hey, welcome back. We are here today with another session of something more interesting. I hope you enjoyed whatever sessions we had before. We talked a lot about views, triggers, stored procedures, user-defined functions, grouping sets, common table expressions, and so on and so forth. And then we also looked at some tips and tricks here and there. So here we are going to introduce some new concepts in the field of ranks, right? So let me give you an example. Suppose you have an employee table, right? An employee table which basically stores some employee information, employee ID, employee name, then say salary, right? And many times what you need to do is actually order this salary. So the common way of doing this is using the order by clause, right? You can order by either ascending or descending. That is the most common way of using it. Sometimes what you would need is you need to rank this. So say for example, one person earns $10,000, one person earns $12,000, one person earns say 9,000, and one person earns say 7,000, right? And let's throw in one more 9,000 and one more 9,000, right? So when you order this, you can order it in many ways, right? Either ascending, descending. So let's assume that we order it this way: 12,000, then 10,000, then 9,000. There are 4 9,000s, or 3, sorry, right? So you can order it this way. And then sometimes you might want to give a rank. This is rank 1, 2, 3, 3, 3, 4, or 6, right? If you just use the continuation. So ranking functions enables us to do this. It allows us to give ranks depending upon what ordering criteria we want. Now, one thing if you see is we have rank 1, 2, and then 3 times because it's repeated. And then instead of having 4, you can have 6 because it's something like 1, 2, 3, 4, 5, 6, a continuation. If you don't need that, if you want a ranking something like this, there are separate functions as well, right? And that's precisely what we are going to study. That's precisely what we are going to have in our demos. There is something called as rank function. There is something called as dense rank function. The next one I wanted to introduce you is called as, bucketing. Bucketing is nothing but, if I say that given this data set containing 6 rows, right, bucket it into, say, 3 groups. So I'll say that the first 2 rows is group 1, second 2 is group 2, third 2 is group 3, right? This whole process of bucketing your data or grouping your data is called as entile. All right, so we look at all the 3 functions, how they are useful, how it's implemented. It's super simple, but imagine a situation where you want to find the second highest salary, right? Second highest salary, this. So basically you can rank the data and then choose rank equal to 2, right? You get the second highest salary. Rankings are very, very useful. Many times you just need to select the data that's not the top 1 or top 6, but basically a specific row number or a specific value over here, right? And that's precisely what we are going to see now. So let's fire up SSMS and start writing some code. So we just saw the theoretical aspect of what is ranking and how is it useful. So let me go ahead and show you some code. So as usual, we'll start with something simple and we'll choose a table from our AdventureWorks database. So let me go ahead and choose the address table, right? So let's look at some data in that. Select star from address. And let me make sure I connect to my server and choose my database also. All right, so if I execute this basically has some a bunch of addresses over here. By the way, we'll see if we can get to the spatial location. It's also a very interesting concept, spatial data. If we have time, we'll definitely record a session in spatial data as well. So if you see something over here, we have postal codes, right? We have a lot of postal codes here, and let's go ahead and use that so that we can look at some data. So let me make some space. So I'm going to say where postal code in, and I'll just choose, say, 98052 and a couple of others. Okay, 98027. Okay, 98055. And let's choose something in the 97 range. Okay, 97205. All right. So we choose some data over here, and let's just make sure that we just display the postal code. So we have some data to play with. All right. First and foremost, what I'm going to do is I am going to introduce, let's put a row number so that we all know what we are dealing with. So I'm going to say postal code and then followed by row underscore number. This is an inbuilt function. However, you need to give some sorting criteria. So you say order by postal code as row number. All right, so let's see how this turns out. Okay, so we have a row number, sequential order, right? So this is how the row number function works. All right, so let's go ahead and give it a rank. So the way you give a rank is using the rank function, and then you must have pretty much guessed it by now, over, and then you say order by postal code as say rank. Okay, so if you see, it has given a rank 1 because all the data is the same, right? But if you observe here, when it gets the next data element, it gave a rank 96 instead of rank 2, right? So the rank function will not give you a continuation, right? But rather it will actually count, it will actually give you the next rank that's not in the sequential order, right? If I have to put it that way. So that's the rank function. And if you really need the 96th row to have a rank of 2, that is a continuation, there is another function for it, and that's basically dense rank. And again, the syntax remains the same, order by dense rank, order by postal code as dense rank. All right, let's see how this turns out. So now if I scroll down and go to row number 96, you see that it has allocated rank 2. However, all the similar data will have the same rank. Okay. All right, let's go ahead and look at our grouping or bucketing that we discussed. So entile is the function, and I say that please bucket this into 10 groups, and then the syntax remains the same, order by postal code as entile, right? So let's see. So you see that it has grouped about 46 rows in group 1, the next probably 46 into group 2, some logical order, and then into group 3, group 4, and you'll find about 10 groups, right? So this is basically grouping, or putting it in buckets. So again, simple functions over here, simple inbuilt functions over here, but really very powerful to start playing around with your data. And then I'm very sure you'll definitely like the dense rank functions, and in fact even the ranking functions, especially when you're dealing with a lot of numbers and you need to order them and choose according to some specific criteria. These functions really help you a lot. So we'll go to the next session and discuss something more interesting. Thank you. All right, welcome back. In this section, we are going to discuss something a little bit different that you might probably not use it on daily basis, but it's a really powerful feature in SQL Server. And if you actually interact with that kind of data, it's at least useful to know that something exists out there. We're going to talk about XML. XML is extensible markup language, and it's nothing but data represented between some tags. Okay, so let's assume that you are looking at email, right? Typically, if you look at a table, if you were to represent all the email components in a table, how would you do it? You will basically have a column saying to field, from field, CC field, BCC field, then your subject line, and then maybe your message, something like this, right? So this is typically how you would design a table or a database, a table in a database, right? All right. Now, if I were to kind of, put this in an XML format, it's nothing but a set of tags. I'll create a tag called to, and then I'll put my data here, and then I'll end it with /2, right? And then similarly, I will say that, okay, next is from. Put my from address here, and then /from. So if you see, it's basically a set of tags, and then I can say that this is my message, this main tag and slash message, right? So I can have multiple messages like this, multiple emails, and this is a way of representing the data, right? So if you think about this, this can be basically a text file, and when you pass this to some other person, he can write his own parser, right, which basically says that, okay, to get the message, go to the message tag, inside that go to the to tag, whatever is between those two tags is, you know, what was the sent to email addresses. Similarly, go inside message and then go inside from, whatever is in between that is from, you know, from addresses. Similarly, he can write his own parser. Now basically what you're doing is you're interacting to everyone using a text file, or you know, you can also have this as a .xml extension file. It's a widely accepted format. Now this document is called as an XML document, right? Now we won't get too much in detail, but actually you can define you know, how your schema should look like. These elements all comprise of your schema, right? How your basic schema should look like. So you can basically say that anyone who implements a messaging structure or an email messaging data should basically conform to this structure, and unless and until you can give the data in this structure, I can very well parse it and, you know, make use of it, right? It can be for anything. So that is basically called as an XML schema definition. Let's not go too much in deep, but schema definition. And there are basically various ways in which actually you can parse this. One of the commonly used is called as an XSLT, right? XSLT, where basically what you do is you take in the XML and transform it to an HTML so that you can you know, make sense of the data. You don't have to visualize it in this particular format. So what you do is XML plus your XSLT. XSLT will be a different sheet, will give an HTML. Now how to parse this data? There is basically you know, various ways. One of the commonly used is called as an XPath. XPath is nothing but, you know, you kind of, there are many inbuilt syntax. Basically you say that go inside message tag and then inside to tag, and you know, whatever is inside that, display that to me, and do that for every message tag, right? So it will give you a list. Similarly, they have defined various syntaxes. You can use for each, I believe it's for each. So there are various syntaxes. So we really don't need to get into that level of detail, but I just want you guys to know that, you know, there is a format in which you can put your data in between tags. You can transform that using separate methods, and then, you know, either output as HTML or maybe load it into a database and something like that. Actually, when we actually discuss make a course on ETLs, or extract, transform and loading, we will actually look at, you know, how to load into a database when your data is from an XML document or from a Excel document or a CSV or something like that. So for now, the only important thing is you should know what this XML is. You know, when you look at a set of tags and data, what this XML is, and how can you store this particular data in SQL Server. And that's precisely what we are going to look at now, how to store an XML document in SQL Server, or how to look at a table and then get the XML equivalent of it, or even one step further, once you store an XML document, how do you write some basic syntax to parse the data, right? Something like this. How to parse the data and get your required information. So let's go ahead and write some code. Okay, we talked about what is XML, you know, how the data is structured, how the data is stored, what are the different ways to retrieve an XML. Now let's look at some basic code, how to deal with your XML data and XML data types. So let me go ahead and create a table, very simple table. I'll call this as, let's give it a, you know, let's give it a column name called as XML data. And if you see, the data type is XML, right? I'll save this and I'll call this a sample XML table. Simple stuff. Okay, so if I refresh my tables, I should find this, and and let me close this. And if I run a select star from this table, my sample XML table, I should see nothing over here, right? Because we haven't really filled it with any data. So let's go ahead and fill it with some data. All right, let me quickly search for some XML data. So XML sample data, let's take it from W3 schools. And let's see if they have something. Okay, so this is how an XML data is represented. Okay, so you have to, you have from, you have heading, you have body, and they can kind of repeat this for every row. So you can actually think of this as these are column names and these are the column values, and this is actually one row. This whole thing is one row. So let us just take this and input it into our data. So I'll just say insert into this table, sample XML table. And what was our column name? It was, I believe, XML data, right? Yeah. So our column is XML data. And then I'll just put these values in it. Oops. All right. And then let's go ahead and put this. Okay. Let's just make sure that either I can do it this way, or let me just remove this altogether. Okay, let's go ahead and put this document in. Okay, now if I run a select star, you'll see that the output is slightly different. It's kind of a hyperlink, right? So if I click on this, it'll actually show me the data in that same format which I had inputted. But if you observe, it's actually slightly different from, you know, how we've been used to seeing data. Okay, so let's go ahead and play with some other table. Let's first look at our sales territory table, right? Select star from sales territory, because we've been dealing with that. So you see that it's in a perfect two-dimensional format. You have columns, you have rows. Now what if I want to convert this into an XML document so that I can pass it along to someone else? So it's actually very simple. There are a couple of keywords you need to remember, and then say XML auto. You can look at MSDN, there is XML raw, XML auto, and so on and so forth. Let's just keep it simple and say that elements, and I want my root to start with. Root is, let's go through it. Let's go through that. Territory, right? And I'm going to select this. And now if I look at this, you see that the root element is sales territory. And as I said, it basically one patch of data is one row, right? Territory ID is a column, name is a column. So your entire data is represented in an XML format, correct? Okay. Let's actually do something else. Let's actually take the same and let's see what happens if I do XML raw. Oops. Minor difference, right? You see that you have the tags row here. So each row, this data is for each row. These are the column names, and that's how it has converted. Of course, you have more control, and you know you can write your own way of rendering this. Let us go ahead and look at some examples where we can actually query a data, right? So for example, when we actually run this query, it actually gives me the entire data set, correct? But what if I just want this value, just this value, TOV, right? So how to do that? Let's go ahead and try doing that. So I'll write select my column name is XML data, right? Then I say dot query, and this is where I need to give my query. So my query is nothing but /note/2. How did I come up with this? Well, if you look at this data, it's inside note inside 2, so slash note slash 2, and that's what is going to give me the value 2. All right, let's see if this works. I'm going to call this column name as 2 from my table, this table. Let's see if this works. Yes, it did work. It just selected that particular element, 2. Perfect. So far it's working. Let's go ahead and try something else. So what if I just want the word TOVE instead of even having those tags, right? We don't really want those tags, but just the actual value. How do we do that? So here there is a small variation. Instead of query, I'm going to use dot value, and I'm going to say that within these tags, give me the first value, right? I don't really need the tags and all, just give me the first value, and that's of type varchar of 10. The reason why I'm doing this is basically the value function actually requires 2 parameters. One is actually your path, and second is what data type will it return. Okay, so let's see if this works. Sure enough, it just gave me the value instead of, you know, those weird tags and stuff like that. Okay, let's try something else. So let's take our sales territory. Oh, this here, and let's say something interesting, right? So let's say give me the top 10 territory ID from sales territory, but I need it in an XML format. So I'll say for XML, it's the same thing that we just talked about, and then elements, and then I specify what is my root tag, and my root tag is nothing but my sales territory. Okay, let's see how this comes up. So if we look at the XML, you see that instead of choosing everything, it has just chosen the column sales territory as the territory ID, right? Interesting stuff. Okay, let's do one thing. Let's try to you know, represent an XML and then actually show it in a nice tabular format, right? So it's like saying somebody gave you an XML, you loaded that XML into a table. Now you are actually massaging it so that the output is actually, you know, in a nice column row wise table that we've been used to seeing, right? Something like this, you know, in a nice format. So let's go ahead and try something like that. So I am going to you know, let's just use this. Let's just use this. So what we're going to do is we're going to use this particular XML. So let's assume that this is the XML given to you. Oops, select star. This is the XML given to you, right? A lot of chunk of keywords and, you know, tags and stuff. Somebody gave this to you and you have loaded it into your database. Now you want this particular XML to be shown in a nice, you know, column and row format, meaning territory ID should be a column, this should be a column, this should be a column, these should be your column values, and this whole chunk should be one row. So basically you're parsing this and then showing it as a nice table. How do we do that? So there are certain standard steps you can follow, and you know, the only change that generally happens is your parsing logic, right? What is the output you need, and accordingly how would you parse it? So let's look at one of the ways of doing this. What I'm going to do is I'm going to declare a variable called XML handle of type integer. Just bear with me on, you know, you will know why I'm declaring 2 variables. The second is my XML document, which is going to store my XML. So it's of type XML, right? So I'm going to do, what I'm going to do initially is I'm going to load this XML document into this variable. So it's nothing but this whole query. This is the query that returns our XML stuff, right? So I'm going to just, whatever is the output returned, I'm going to store this here. So my variable is going to hold, this variable is going to hold my XML document. Next, what I'm going to do is I'm going to use inbuilt function called sp underscore xml underscore prepare document, right? And what I'm going to do is I'm going to pass in a XML handle as an output variable. We talked about output variable, and my second variable is going to be my actual XML document, right? So just bear with me, you will come to know when this starts converging. And then what I'm going to say is select star from, now this is the place where I need to use my parsing logic. So to do that, I'm going to use the open XML function. I'm going to pass in my XML handle, and then I'm going to pass in, my parsing criteria. In my case, it's sales territory slash, let's see, sales territory slash sales dot, let me copy this one, right? So anything that's inside that basically needs to be parsed out. Okay, so and then when I say with the column should be territory ID, and that should be an integer, and then sales YTD should be money. Oh, by the way, this basically says the number 2 basically says go two level down, right? So you stored your XML into a variable, and then basically you're using an inbuilt function to convert that XML and giving it some parsing logic, right? And then putting it into under these two columns, territory ID and sales YTD. Okay, and then there is a command for freeing up your resources. So I'm going to say sp xml remove document, and then pass in the XML handle. Let's see if this works. So 2 variables declared, loading the XML document into a variable, then using some inbuilt functions, and then defining my own parsing criteria, then putting it into certain columns, and then releasing resources. And it didn't give me any results. So let's see what is the mistake that we did. Sales territory, this one. So by the way, all these are case sensitive, so let's try that one more time. Okay, so we did get this, right? So the whole logic of parsing the document and all the steps are pretty much standard. I know it can be a little overwhelming, but the steps are pretty much standard. The place where you would play around with is basically this particular area where you have to write this parsing logic, how you want that, and then put it into kind of some columns. Now everyone has their own style of coding, right? And one of the things that I use is if I have a document, I generally put the raw document in a table and then do the computations. Now there have been instances where I have got XML files that are in gigabytes, right? Huge amount of XML data. So then you have to take a call as to, do you need to really load everything and then do the parsing, or actually just load the stuff that you really need. So that's where you start playing around with your parsing logic here. But again, this is not something that you would basically encounter in day-to-day situations. Of course, there are programming languages, libraries, etc., which allow you to parse an XML file, a CSV file, a JSON file, and something like that. The idea is SQL supports this XML, and then I just wanted to show you that if something like that comes your way, there is a facility available in SQL, and there are ways in which you can parse this and put it into tables. Hope you liked it. We will be coming up with one more with a new session, something more interesting. So stay tuned. Hey, welcome back. So now we are going to discuss a little bit about partitions. So we looked at a lot of concepts, right? In the last few hours, we looked at right from views to triggers to stored procedures to insert statements and so on and so forth. So why is partitioning so important, right? So if you kind of imagine this whole situation, we have a database and then we pump in data into this, right? And naturally this database will have tables, right? Now when we insert or when we retrieve queries, retrieve results, we are basically running some statements against this particular table. Now, when we run these statements, what it is doing is, depending upon how data is stored, it will actually scan this entire table, right? Now, what if this table contains, say, 5 billion rows, right? And you have a very complex select query with a very complex where clause where you have very complex conditions. Now, what will really happen is it will start scanning through each row and see what satisfies your conditions and then accordingly retrieve the data for you. But the downside of doing this is, since your data is very, very, very huge, it will take time, and it's not really very efficient also in order for you to manage the database. As such, there are many ways you can handle this, and one of them is called partitions. In partitions, what you're doing is a single table you are actually splitting or partitioning depending upon some criteria, right? You could say that these could be our partitions. Anything that's less than, say, updated in the year 2009 goes here. Anything between 2009 and 2010 goes here. Anything 2010 onwards would go here, something like this, right? Now, when you actually search for a record, in say 2010, what SQL will do is it will just search in this particular partition, right? So what you're doing is you're actually limiting the scope of your data retrieval, and it speeds up your query. And then at the same time, you can actually maintain the database better as well, right? Another criteria could be anything with an ID from 1 to 1 million goes into partition 1, right? 1,000,001 to say 5 million goes to partition number 2, and so on and so forth. So you can be innovative in defining your partitioning criteria. And what you do is, to put it very simply, you're just breaking the table into smaller pieces, and at the same time enabling SQL to just search or just insert or run your statements within those smaller pieces which you just created. Now, one thing to remember is, when we start writing some code, you will see that this might not work in your environment, because partitioning is not something that's supported in SQL Express, and all our examples which we have seen are basically based on SQL Express. You need an enterprise edition, right? Because see, partitioning is a concept which will basically be useful when we have huge amount of data, and the free edition is basically for your personal use. When you have huge amount of data and you're storing which is deployed in your company premises, you're storing huge amount of data for your warehouse, etc., you need to install the SQL Server Enterprise Edition, and that's where the concept of partitioning, etc., will be enabled. In any case, I will be uploading a code piece of this, in which you can at least see that if you are entered into such a situation where you're going to deal with huge number of data and your query is getting slower and slower, how can you really break that particular table into very logical partitions so that your query and indexing and all these become super easy. So stay tuned, we'll walk through some code as well.
Hello everyone. In this screencast, we'll be discussing something on partitioning. As the name suggests, partitioning is essentially you divide the data. So just imagine you have a huge table, and it has some sequential numbers from 1 to 1 million or something like that. So what you could do is basically chop up that table into certain ranges. So you'll have something like 1 to 100,000, 100,000 to 200,000, and so on and so forth. So essentially what you're doing is chopping this entire table into 10 different buckets. So now whenever someone queries it basically searches just those particular buckets, and the query also runs a bit faster because all these are divided into their separate file groups. That is essentially one of the main reasons why you would use partitioning, that your tables are pretty huge. Of course, there are a lot of other uses as such, but just to keep it very simple and try to get that idea. So what I'm going to do right now is let me just make a DB called as a partition DB.
Or before doing that, let me just show you something like go to files, and then now I'm just going to explore the MDF and the LDF locations. So here you see that all these databases essentially have two files. One is the MDF file, and that's where your data gets stored, and the second is the log files or the LDF files. So what we are going to essentially do right now is that we are going to split this MDF files into a couple of other files, into secondary files, and that's essentially what we are going to do in partitioning. So I'm just going to minimize this. And so before doing that, there are a couple of steps that we need to perform. Like, at the very first beginning, we need to create something called as a partition function, wherein we're going to say how we're going to divide the data. And then secondly, what we need to do is actually create a partition scheme. Now these two are like totally independent of the table, right? This is something which you can apply across different tables. So let me just start off by creating a partition function, and so let's do something like this. Let me create partition DB. It's a simple DB. It has two files right now, and one is the MDF file, and the other is basically the LDF file. And what I'm going to do is the first step, that is to create the partition function. So to create the partition function is pretty simple. It's called create partition function, and I'm going to give it some name like customer partition function. So we'll build the customer table, just a simple table which has, say, customer ID from 1 to 50,000 or something like that. We'll just build it on the fly. And we're going to say on range right, as range right, for values, say 0 to 1000, then the next bucket should be till 2000, then from 2001 to 3000, 4000, and 5000. And that's it. So once we create that, oops, did I make a mistake? Yep. One thing what you need to do is, you need to specify the data type of the partition key that we'll be using. In this case, it will basically be something like an employee ID or something. So that has to be an integer. Now let's try that again. And we have created the partition function. So if we go here, you'll see the partition function that we just created. So again, if you see, we have never mentioned the table name or anything at this point of time. We are just saying that, okay, we're creating 5 different buckets, and you need to basically divide a particular table, whichever table I'm going to associate this, and put it into this 5 different buckets. And we have explicitly specified the ranges also. The second thing what I'm going to do is I'm going to create a partition scheme. So again, the syntax is exactly the same. Create partition scheme, and I'm going to call this as customer part scheme as partition, and I need to just associate the function that I just created. So I'm going to just copy and paste it over here, and then basically I need to say in what all file groups do I need to put these data. So 0 to 1000 I'll just call it a file group called as FGP1. I haven't created the file groups as of now, but I'll definitely create it. FGP2, FGP3, FGP4, FGP5, and anything about 5000 should go to the last bucket, that is FGP6. So this is some just random names I'm giving. I'm going to create these file groups just in a minute, but I'm just creating the schema as of now. So I'm going to right click over here, go to properties, and I'm going to add a couple of file groups over here, and I'm going to call this as FGP1, FGP2, FGP3, FGP4, and FGP5, and FGP6. And once that's done, I'm going to give it with some logical name. So I'm going to call this as FG1, FG2, FG3, FG4, FG5, and I need one more, and that should be FG6. And I need to associate this with the proper file groups that I just created: FGB2, FGB3, FGB4, 5, and 6. So once this is done, if I go back to my and just filter the date modified, you should see that, a couple of NDF files also along with this. So let's try running this. So yeah, I was able to create the partition scheme. So essentially what we have done is we have created a function, we have created a scheme. Now what we need to do is basically associate it with a table where basically the employee ID or some integer key is going to have values like 1000 or below 1000, then greater than 1000, so on and so forth, so that it can automatically just put it into the different buckets. Let me just create a table, and I'm going to create a very simple table called something like, let's call this as partition itself. And that should have an employee ID, and I'm going to have that as an int identity, so that it can just auto increment. Let me just run a while loop or something and then populate about 10 to 50,000 rows or something like that. And I'm going to introduce one more column called as employee date, and then that will basically be just date time. And I need to say that, okay, this is basically going to use the cust partition scheme, and the employee ID is basically the key that I'm passing over here. So let's create this table, and we should see it in the tables. And now what I'm going to do is I'm just going to run a while loop and then populate a couple of thousand rows in it, so that we can just see how it divides them into different file groups or different partitions. So I'm going to say set I equal to 0, and while I is less than, say, 50,000 or say 20,000, or just 10,000 is also fine, because we would be easily able to test that. I'm going to say begin, and I'm going to insert into partition employee date values, and I'm just going to populate using the get date function. And I'm going to set I equal to I plus 1. So let's just run this. This should take a minute or something, and then we should be through with that. And oh, it's almost done. So let's try selecting a few values from the table. So there is a function called partition, which will basically give us the partition number. I'm going to just use that for now. It's $partition, sorry. And then I'm going to say the cust partition function, the function that we just created with the emp ID, as the partition number, and also give me everything else from the partition table. So what I'm basically doing is I'm just selecting everything with the partition numbers. So if I run this, you see that from 1 to 1000. Let's see the switch over here. 1 to 999 actually. It has put in partition number 1. The rest you can see it will be putting it in partition number 2. Then when it reaches greater than 2000, it's going to put it in partition number 3, and so on and so forth. So anything about 5000 would be put in the last partition. So this is basically a very simple example how you can use partitioning of data. There is, there is a UI technique also, like, you could really just, click on the table and then you can say storage, and then you can really create a partition from here. It'll just walk through a wizard. It'll ask you, what is your key partition column and such stuff. And then you can really create your schemes and then partition functions, etc. and then partition your data accordingly. This is another wizard for managing your existing partitions, but it's kind of the same thing which we just talked about. I just wanted to make sure that we go through it via a query. The UI technique is also very simple, and we could really leverage that too. Thanks for watching.
Hello and welcome back. So in this particular session, what we are going to do is we are going to discuss the concept of dynamic queries. Dynamic queries. Now, dynamic queries is really very interesting, and you will find it more and more useful when you start writing some complex applications or certain things where you really won't know the query during the time of programming, right? So to give you an example, let me also introduce one more concept called as pivot. Right? If you look at a typical Excel pivot, what do we do? If we even consider our sales territory, we had country region code, right? And then we had groups, and we had sales YTD, right? This is our typical this is the same example we have been following through, where we say that country region code could be US, and this could be North America, and sales YTD could be something like $78 or something, right? And another example could be Europe, and then this could be something like $70 something. Now, when we were to pivot this, it's basically interchanging your rows and columns. So we'll say that your country region code US, right? And you will make these values as columns, right? So North America and say Europe, I'm just making this up, right? And you'll start pushing in values. So North America will be 78, and then you'll have something like EMEA has $70 and something like that. So what we have essentially done here is we have interchanged our rows and columns. Now, if you think about it, we will not know these column names during when we start coding, right? These column names are purely dependent on what values these tables have. This is a perfect example where you can write a dynamic query. So dynamic query is nothing but a string, right, that you generate, and after the string is complete, you just execute the string, which basically will contain the query, right? So what you do is you start saying, okay, my string should start with select, and then you say okay, then you have another variable which will basically have values like NA, Europe, or something like this, which you dynamically query a table and get it. And then basically you say that my final SQL would be something like var plus var1, which is basically select star from so on and so forth, right? So this string you're dynamically generating and executing it. That's basically called as a dynamic query. And so we will have a look at how we can use dynamic query, how can we construct a string dynamically so that during the time of compilation the query, but you really don't have to customize the query for every need. It will be dynamically customized, it will be dynamically generated. And we'll also walk through a brief example of how pivot queries how pivot queries look like, and how can you use dynamic queries plus pivot operations in one shot to get your desired results. So let's jump into some code. All right, let's go ahead and write some code for a pivot table, right? And then we can also look at how can we write the same thing when we know something about dynamic queries. So let me go ahead and show you some data, and we'll use our typical example, select star from sales.sales territory. And oops. And some data.
it has some data. And what we are going to do is we are going to select just a couple of rows here, a couple of columns here. So we're going to definitely select the country region code that we just discussed. We're going to select the group, and then we are going to select the sales YTD. From our table. So limited data to work with. So now what we are going to do is we are going to dynamically pivot this. So we're going to say that our output would look something like this. Let me just draw a mock-up. So it'll be something like country region code. The second column would be North America, right? The rows become the columns because we are pivoting it. Third would be Europe. And then your values would be something like US. North America will have some value 23, and Europe will have some value, something like this, right? So if you think about it, we are just transposing our rows and columns together to get the pivoted value. So let's see how we can do that. First of all, to do that, you will need to know when you code this, you will need to know the column names. You basically have to hard code the column names, right? And this is basically what I was talking about in my just the previous session where I say that at the time of writing code, you might not really know all the stuff that goes into the query, and that's where a dynamic query comes into play. But let's assume that we know the columns now, and let's proceed with this so that we can just show one simple example. Territory, sales territory, and then what we do is we use the pivot keyword over here. We say that pivot, and then what should go inside the pivot? Sum of sales YTD, and this should be for the group column. And you say in give the column list. So you have the column as North America, then you have Europe, and you have Pacific, right? So a lot of hard coding here, but this is precisely the same point I wanted to drive here. Okay, and then you just give an alias over here and see how this looks like. Country region code, oops. So you see that though the columns North America and Europe, there were rows before and now they are part of columns. This is typically how you would pivot in Excel. But the downside of doing this is at the time you code, you need to know this. What if there is a new value that comes in tomorrow, right? Maybe Australia, something like that, right? How would you know? Would you keep on changing the queries every time? No. So that's where you can actually make use of dynamic queries, where you actually construct the query every time it is run. So it's basically nothing but a concatenation of a set of strings. So you say that declare, maybe I'll declare a variable called SQL string, and I'll give this a varchar of say 2000 for now, right? And then what I do is I set the SQL string value as select country region code and group, just keeping it simple here, comma, and then I construct others dynamically. But I'm just saying that okay, set SQL string equal to SQL string plus let's keep it super simple, sales YTD from sales.sales territory, right? And what we do is we can just print out this SQL string to see what was the code it generated. But in order to execute this, we use the exec keyword and then just pass in the string inside it, right? So before we execute it, let's see what is the string it generated. So this is the string it generated dynamically. So you might as well put in North America, Europe, everything dynamically by querying the table, but you can always execute the string, and this is the result you get. So you see that this is nothing but a concatenation of strings, multiple strings, and you can kind of construct the string however you want, query multiple tables, join multiple tables, and construct this. But at the end of the day, you really are not writing, you really do not need to know every element. You can construct things on the fly and then finally execute this. So Dynamic queries are very super powerful. I use them a lot to dynamically construct queries, to dynamically construct reports and stuff like that. So hope you liked it. A very powerful way of writing queries. Please use them in your requirements as well, and also check out the assignments and quizzes. Thank you.
Hello and welcome to this session. So in this session, we'll look at how to use the file stream functionality that SQL provides us. So let me just quickly create a database. So the first step to use the file stream feature is to create a database which is file stream enabled. You can also modify an existing database to do so. So I'm just creating a new database, and let me add a file group over here. I'm going to just call this as file stream underscore file group, and I'm going to get back to my database files and add the new file group over here. So I'm going to call this as file stream underscore fm, and the file type should be file stream, and I just need to give some default location for it to store. So let me just use this one and call this as fn1 actually. So everything has been set and file stream db already exists. So let me just create file stream db underscore demo. Okay, so we do have a database which is file stream enabled over here, and then there are absolutely no tables over here. So what we are going to do is we're going to create a table and then store a file in that table. So one thing to notice over here is I tried playing around with this and then try to do it via UI, but I didn't find all the attributes that we need to set in order to store files over here readily available in the UI. So I guess we'll have to use the query based approach in this case. So let me just quickly write a query to create a table. I'm just going to create a table called as let me call it as files, and then it'll basically have a doc ID, just a plain ID, and then there is a rule that in order to have a file stream enabled table, you need to at least have one column which is a unique identifier which has GUIDs in it. So that's what I'm going to do now. So I'm going to just define a column called as doc ID with a unique identifier. I'm going to say this cannot have null values, and this has GUID call, and this is basically a unique ID generated for each row. So we have defined column 1, and then basically in column 2 I'm going to just store the actual document. So I'm just going to define a column called doc, which is going to store var binary max, and then I'm just also mentioning the attribute for file stream, and I think that's it. So let me just create this table. So that's done. If I just refresh the tables over here, I'll see the new table that has been created. So what I'm going to do is I'm just going to add a row which is basically going to be a file, and for that I'm going to use the open row set. So let me just quickly go to my C drive, and then I'm just going to create a folder called files, and then I'm going to create a text file over here as test, and I'm just going to have something like 1 2 3 4 in it. So I'm going to load this file into database, and let's use open row. I'm going to declare a variable called as doc, and the data type as var binary of max. I'm going to say select doc. I need to cast it var binary from open row set, and then I need to give the file path for this one, and I think the file path is c/files/test.txt. So
once this is done, I'm going to just use this variable which has the var binary information for that particular file that I just created. I'm just going to load it into our table as a row. So I'm going to say insert into files, and in the document column, values doc. Oops. Okay, let's try that one more time. Okay, let's just partially run this code, and now let me just insert this. Okay, so I'm going to run a quick select query over here. Select star from files, and you see that the binary information is stored over here. So I'm just have the column name, select doc from files, and you could also use something like path name. So that will basically give you the path where the file is actually stored. Oops, I think. Okay, now we should be good probably. Okay, so you see that this is the path where it's storing the file. So this is the advantage when using file streams. So you're no longer limited to the database limitation, wherein if you're storing it as rows, there is a 2 GB limitation for each of the data that you can push into a particular column. And then here you're actually using the file system, and then the good thing is that the larger your file system, so you're no longer limited to that 2 GB limit. You're just limited to whatever space you're having on your file system. So in that way, we could really use our file stream functionality to store our files, etc. Thank you. Hello once again. So in this session, we'll talk more about free text search. So let me just fire up Management Studio. And I'm going to connect to my AdventureWorks database. And let's just play around with a couple of tables. So I saw that there is a table called production.description that has some text in it. So that might be a good table for us to play with. So just to give an overview, so whenever you search for certain strings in your queries, using queries, you generally use the like keyword. Like for example, it will be something like where description like, and then you give some kind of a string. So I'm going to say something like something like this. And if I search this, then it's just going to match the pattern and return you the appropriate string. But now the problem is that we are limited to searches over here. I mean, what if we want all forms of strong or stronger or strongest, all verbs or nouns, everything to be searched? Or for instance, you say that okay, search for the keyword IE, but also return me results which actually stands for Internet Explorer or Internet Explorer 5 or something like that. So, and the third thing is that, of course, if you use this kind of a syntax, your query becomes very slow because it does a sort of character by character matching. and then it matches the pattern and then returns the result for you. So for that, in SQL Server 2008, you have the full text search, and that's what we are going to look at right now. So to even start using full text search, there are a couple of steps that you need to perform. So first thing what I'm going to do is I'm going to right click on the database, and then so just a second. Yeah, it's on the storage actually. In the storage, you see there is something called as a full text catalog. You need to create a catalog. Let me just delete the existing one. And what I'm going to do is I'm just going to right click on this, and then it pops up a sort of wizard. And I'm going to just create a catalog out of this. I'm going to call this as demo catalog, and then click on OK, and it's going to create a catalog for us. Second, what I need to do is go to the table. That should be production dot product description. Yeah, this one. And you'll find something called as full text index. So first step is to define a full text index, and it's also a pretty much self-explanatory wizard. You just have to run through them, and the first step is it's just identifying the unique index, and then basically it's just identifying the text columns. Here it is description, and let me just click OK, and I'm going to use our existing catalog. Click on next, next, and finish. So this is done at this point. So next what I need to do is I need to populate this entire thing. So there is an option called start full population. So I need to just enable that, and then once we are done with these 3 steps, we are good to go with our queries. So let me just fire a few queries to show you a couple of examples. So I'm going to say select star from this table, product description table, where free text, I'm going to say search in all the columns for strong and sturdy. Let's see what this gives us. So it's just going to look at all the columns for strong and sturdy, and this should return a couple of more results. So this is one way you can use it. It's basically going to look for the keyword strong or any forms of it, and then also the keyword sturdy. The second thing that you can really use in your queries is something like this, where contains, and then search in all columns for the keyword strong. So basically, it just looks for, the sentences which contains the keyword strong, and then it returns the result to you. And just to give you an overview, these things are much faster. And then, even if your tables are pretty large, you see that the returns are, the results are returned pretty fast. So let me just try out a couple of more things just to give you a more broad example. I'm going to say search for strong or sturdy. So as the search query suggests, you're going to search either for strong or sturdy. Okay, let me show you one more thing. So here what we are going to do is we are going to look for strong, which basically appears near the word sturdy, which should typically be blank. I mean, we don't, yeah. So we could search something like strong near rims, and it's going to return the sentences which has the keyword strong and which appear near rims. So you could also just try out something like strong near durability. Let's try this out once. So you see that there is a strong keyword and it appears nearby durability. So you can just customize it however you want. And then situations wherein you want to also search for all different forms of a particular word, there are a couple of
inbuilt keywords for it. So I'm just going to use that search in all columns for forms of inflectional, and then just one more thing for the keyword, say strong. Let's try this. So you search for strong, it does return stronger, and so on and so forth. Also, basically, you can sort of create your own thesaurus, your own XML, and then sort of define things like IE can be expanded to Internet Explorer, or IE5 can be expanded to Internet Explorer 5, so on and so forth. You can totally define your own XML structures as well. So let me just quickly show you where you can find this XML structure. I'm just going to say C drive program files, or let's just see Microsoft SQL Server. In the SQL and in FT data, you'll find a couple of XML for each language, and it's like things are commented out over here, but you need to uncomment them and configure them as and when. And then basically this is the thesaurus you can use to kind of search to actually configure your search or expansion, how it should really happen. Like if someone searches for IE, you expand it as Internet Explorer. Basically you're saying that Internet Explorer, IE, IE5 are all the same, and then if these words exist, then return the same when one of these keywords is searched for. So I would really recommend referring either MSDN or any other material to find a long list of keywords that you can use for full text searches. Thank you. Hello once again. In this session, we'll discuss more about the geography and the geometry data types. So when you talk about geography data types or geometry data types, there are two aspects that you're dealing with. So one thing is basically, it's basically the Euclidean or the planar surface that we can consider is basically the X and Y axis. That's the geometry data type. And SQL Server provides us a way in which we can really store some data which is pertaining to geometry and do whatever calculations we need. And it also has a lot of inbuilt functions which we can use to derive into a lot of conclusions. The second data type is basically the geography data type, and that really considers the geodetic or the round surface. Right, so when you say that if you want to calculate the distance between, say, two coordinates or two places, right, from say place A to place B, you cannot really just subtract the two distances or the two coordinates and then come to a conclusion. So there are some inbuilt methods which help you to do so. So that's exactly what we are going to discuss over here. So let me quickly fire up Management Studio so that we can walk through some very basic examples. What I'm going to do over here is that I'm going to create a database called as, say, Spatial DB. And let me create a table over here called something, and we'll create a couple of columns. We'll call it as ID and an integer. And I'm just going to keep this as entity specification. I mean, I really don't care what this column is, but just so that we have some data to work with. And the second column is where we are going to store our geometry data type. So I'm just going to call this as spatial data, and the data type is going to be geometry. Let me call this table as spatial DB, or just spatial, because it's a table. And you see that we have just created a table with absolutely no data in it. So what I'm going to do is I'm going to insert some values into it so that we can have a quick walkthrough with an example. And insert into spatial, I should have called the table something else so that we don't have a keyword conflict, but anyways. And what I'm going to do over here is initially I'm going to insert a point, and with the coordinates 7 and 12, so X and Y. So let's just insert this, and let's make sure that we are pointing to the right database. Let's try that one more time.
Okay, so now when we just select the data, you see that the spatial data is represented here. And but one strange thing that you find here is 3 tabs. So apart from results and messages, there is also a spatial results tab. So let me just click on that, and you see that there is basically a graphical representation of your data over here. Now we've just inserted a point, so maybe that's not visible. Let's try that one more time by inserting something else. And this time I'm going to insert a line string. And it basically, as the name suggests, it's just going to insert a line from 0, to say 7, 8, just X and Y coordinates. And let's try this one more time. And if I just select this, I should see that my spatial data is represented over here. When I click on the spatial results, you can see that the line string that we just defined has been drawn over here. Likewise, there are like many functions which you can use. Let me just show you one more thing, like say what a polygon. Let me say it should start from 0, 0 to 8, 5, and then it should go up till 9, 6 to 10, 0 to 0, 0. I'm just choosing some random numbers over here. So let's see. Let me insert this, and let me select some data, and let me click on spatial results. So you see that this is the polygon that we defined. Now this is just plain data insertion that I have just shown you, but there are a ton of functions which help you with calculations also. I would highly recommend that to just go through that functions. You can just refer MSDN. But there are a couple of ways also in which you can retrieve data. For instance, this I can just say spatial data dot toString, and that will basically give me say spatial data. So you see that that will give me a plain English text instead of this geometry data. And you see that these are the data that we just inserted, and we are just reading it in plain English. I can just show you one more thing. Let me just have something like spatial data as GML, as spatial in text, something like that. So let's select this, and you see that it's kind of an XML representation of the data that you inserted. So let me just click on something, and you see that it actually gives you the coordinates in a nice XML format. So this is basically the 2-dimensional plane that we are considering over here, and there are a ton of functions you need to look for doing the needs that you need to achieve. And again, it's just two-dimensional. So when we want to extend it to a 3-dimensional, that's where geography data type comes into place. So here we are dealing with latitudes and longitudes, and basically representing stuff on a map or a sphere or something like that. And needless to say, even geography data type has a lot of functions which you can use to calculate distances and whatnot. So before we go into too much of details into that, I'd like to show you two things. So all the geography data that you have is basically you can get into something called as a shapefile. So shapefile will have just the geography data of what you need to represent in a map. It can have something like as simple as give me the population of each state in the United States. So you can just have a shapefile which will have the geography information along with the population information, and then you can really use that and plot it in a map or something like that. So while surfing through the net, I actually found two links over here. Let me just quickly fire up a browser. Oops, sorry. and then you see that this is basically a tool that helps you to upload a shapefile. So if you have a shapefile, this tool will take that as an input and then create the necessary tables for you, and then it'll upload it to any database that you want, and then you can really play around with that. Also, I found that the vdstech.com has a lot of royalty-free shapefiles that you can use. I would just suggest you to read through their terms and conditions, but this is a good website that I found, and we could just use some of this in our demo. Let's see, world data, street map. Okay, let's see, US states, and so this is a zip file. If I just extract it, you will find that there are a couple of shape files over here. And let me also download this tool for you. Back to download page, there should be a download link somewhere. Yep, let's try this. And let me just quickly extract it, and you'll find a exe file over here. Let me just double click on this one, and what I need to do is I need to select first of all the shape file, and then this is basically your server name. And let me take spatial DB over here. So you have a server name and a database name, and I need geography data, and these are the columns which it has. So I'm just going to upload things to the database. So you see that I had about 51 rows, and if I just refresh my table over here, I should find another table called as USA_ST, which is basically all these columns. However, if you see the last column, which is of like type geography. So let me just select the first 1000 rows in this. That's just 51 rows actually. And you see that for each of the state, and the state information in geography is represented this way, and then it has a couple of other data associated with it as well. And if you click on the spatial results, you find that it is represented as a map. So you can actually plot any of the data that is provided here along with the geography data in a map. So let me just select, say, females, and then it gives you a count of the number of females corresponding to that particular geography. So it is just plotted the data in a map. Of course, you can really customize this however you want, and then all you need is associated with a the geography data type and have the appropriate shape file or something like that, and then you can really plot it to a map. And also I would recommend you to use the MSDN for exploring other functions which you can have to calculate distances, etc., and then really use them into your SQL as and when necessary. Thank you.
This completes our course on SQL, where we covered some advanced concepts like views, triggers, dynamic queries, pivoting, ranking, and so on and so forth. The whole point of this course was to make you aware of what are the different things available out there, so that when you are given a business problem, you know what all exists and you can take it further from that point. We also have an introductory course in case you are starting off early. So I have recorded a very basic course as well. So it's called Introduction to Databases. Please check that out as well. If you have completed this course, and I hope you like this course, there are a couple of things that you can do as next steps as well. So when I get time, I'll definitely try to record some more courses around these. So the first thing is, we really didn't cover much of database administration aspects, right? DBAs, if we DBAs are the set of people who actually do administration tasks like backing up databases, performance tuning, and so on and so forth. So some of the things that are covered in this particular field would be, as I said, backing up databases, performance tuning, deadlock recovery, and so on and so forth. So that's a little bit different field, but knowing how to write some complex query might help you out, in creating some complex scripts, some maintenance plans, and so on and so forth. We'll try to cover that as well in the coming sessions, how to use profilers, how to look at badly performing queries, what are the different things we can do, like indexing, what are the different indexes, and so on and so forth. The next is ETL, or extract, transform, and load. I feel this is a very interesting area and a very important area as well. We looked at how to query data. So in this particular area, what we will do is we will look at how to get data, right, from different sources. So data is spread across in Excel files, in JSON format, in XML file, in different databases like Oracle, MySQL, Hadoop, maybe certain things in the cloud as web services, and so on and so forth. So there are different tools out there which will help us grab all these data and then put it into databases. It is really essential that we know how the data should be designed, how the data should be cleaned up. Different sources might be using different ways to store data. Like for example, one of the systems may be storing gender as male and female, other may be using just the letter M and F, and so on and so forth. So these concepts basically tell you how to get data from these different sources, how to clean that up, how to store the data so that it can be queried efficiently. The next is dimensional modeling and cube. This is actually getting the data in a three-dimensional format so that it is very easy for you to query. This is also a very interesting field, very interesting area where we look at what are the types of aggregations, what type of relationships we can build between tables, what are dimension tables, what are metrics, what are fact tables, and so on and so forth. The next is, of course, when you have data, you should have solid reporting. There are lots of tools out there. I like SSRS and Tableau a lot. I have done a lot of work in that area, and these tools provide some powerful visualizations so that business can really interpret your millions of rows in a nice chart on a nice graphical format. This field is also really very interesting. It basically helps you translate your business knowledge into something more representable. So something to look out for. And the last is the upcoming field, data science and machine learning, where we basically discuss about predictive analytics and anomaly detection and so on and so forth. So it's a more statistical based approach to examining things, and it's a very interesting field as well. So as and when I get time, I definitely start recording some videos around these topics as well. I hope you enjoyed this course. Please leave me feedback, and please let me know if you'd like to see something different in courses. Please use the discussion forum to ask questions so that others can answer the questions as well. So until then, see you next time. All the best.